Okay, we are live on YouTube and need somebody to, shall I announce it on Facebook? Okay, it's on Twitter, it's on Facebook. If James is around, you could put it up on LinkedIn or somebody else could. Maybe I'll do it on LinkedIn. Now, you're recording audio, are you?
Not yet, but
Okay, so turn on your micro. You don't have to record the session just yet, but locally, but at least have the audio going through so people live on YouTube can check they're getting audio reasonably. And just check the microphone. It's this microphone. It should be the Rode one. I can't get into LinkedIn. I suspect the internet link. Oh, there it is. It's up. Okay, it's up on LinkedIn. Can somebody confirm the live link is working? Printed out over there. All the names are over there.
Oh, I didn't see mine.
Yours wasn't there?
I'm not sure.
Okay, yours wasn't added. Let me see if I can fix it. Otherwise, I think you might have to do without. I'm sorry, Robert. Yeah, sorry, bit late now. I'll try and do it for a second session. It's surprisingly difficult, this software adding a name. You have to actually uninstall all the software, install an older version, add the name, uninstall the old version of the software, install the new version of the software, print it. Do not ever buy a Dymo. They are horrible things. So, all right, we are live on YouTube, by the way. All of that rant was recorded.
Yeah.
Yeah, good stuff. And we're getting audio coming through on the live link?
Yep.
Great. And maybe we'll check somebody remotely. So Craig, if you can hear this, can you check the live link and then tell us in the chat if it's going okay?
Yes, it's going well.
We're not getting your audio, Craig. Just send us a text message in the chat if the live stream, I don't mean the Zoom stream, Craig, I mean the live stream that's linked on Facebook. So just want to make sure that people in the public, great, okay, Craig's confirmed. Thank you very much, Craig. Great to have some people helping remotely. That lighting is a lot better with that little tick box, isn't it?
It really is quite a bit.
Yeah. Morning, Leonard.
Hello, mate. Get all ready to
Not
go.
going to set up a Callisto just there?
We can actually, we.
You could during a lunch if you wanted to have it there as an exhibit, but you'd have to pack it up each evening, I guess. Actually, we have the room all 3 days, so maybe we don't.
We actually brought down two factories.
Okay. Yeah. If you want to grab that spot or up the back,
Yeah, those are the.
we've got little ones up the back, but if it doesn't fit there, you go here. Either way,
That's probably a great
Yeah.
spot if it's out of the way, but yeah.
most welcome.
We can do that, in a break.
Yeah, in a break. Yeah. Okay. Good stuff. Those watching live, we'll be starting in just a few minutes' time. I'm sorry? My screen's turned off. Ah, well, that's annoying.
Yeah. I don't think it's this. I think it's this.
Just not giving and get blue with guns.
What's working? It's Cerny.
It was working just a second ago. I'm just going to unplug and replug. No, turn it off and on again and hope.
Hey, James. James.
I'm tempted just to turn it off and turn off the projector. It is projecting, but it's just not getting. The other thing is the cable could have pulled loose.
Hello.
Oh, that did something. That did something. Right there.
There it is. So this cable can be knocked. Okay, now we know where to look.
Either the camera or the screen are.
All right, great. Yep, thanks. Yeah, live stream only? Great. Okay. So starting, for those on the live stream, we're starting the main talks in 10 minutes time. We've got about half the people seated so far.
They're playing in the screen a little while.
Well, we need that light off. So I'll see if we can. Yes.
Is that you, Randy, over there?
right. I'll see if that's better, but with it will be better when I'm sharing my screen, because people will be able to see. So I'll just share screen there now. So that should be a little bit better. Certainly, so people can see the screen properly, hopefully, as it coming through directly. That working? Yep, great. The live stream. Yeah, it's on Facebook and LinkedIn and Twitter. Discord channel. We were going to get it, a sky written, but couldn't quite organise the smoke in time. Sky writing. Grab it off Facebook or LinkedIn and add it wherever you like for the live stream. If you don't have your name tag, they're up the front here. Morning. Is that better with the lights dimmed? They've just dimmed them. It's a bit better on the live stream.
A little bit, yeah.
Excellent.
Live stream is great.
That's good now?
Well, yeah.
They're okay. Now, some of you have been using my Wi-Fi hotspot over the last few days. If you can stop using it now, since you just the organisers. So if you were using the Tridgen mobile hotspot, please turn it off now. That'd be appreciated. Thank you. A lot more power increase goes around the chair. A lot more power to desks. The last one was first talk too, but that won't last later. And then this microphone. For when you're giving a presentation. So you'll sit back here, you think? You won't be able to see the screen as well. You might be better in one of the front rows there. That's true. Yep. Yeah, I don't know how much we're going to get. We haven't advertised it much.
I'm singing. Say it again.
Morning. Did you get your power supply back, Vince? We actually physically drag you off the stage, you know. Then. Right, if everyone could take their seats now, if we can. Pardon? I think we should start recording now. There's always one. That's all right. Okay, good morning and welcome everyone to the Archipelago Developer Conference 2023. So it's really great to have everyone here in person. We've had the last 3 Dev Confs online, and while that's worked quite well, seeing everyone face to face and actually having the flying sessions and being involved directly, looking at the hardware is fantastic. So very much welcome to all of you. And I hope you've had fun over the last few days. If you've been here for some of you got here on Monday, and we've had a lot of flying and a lot of excitement. So it's been great. And then we've got 3 days of talks now. I've got the schedule up here. The way it works is we've got 4 talks in the mornings, and halfway between those, after the first couple of talks, we're going to have morning tea, which will be up the back there. So the morning tea will be brought in, part way through. Lunch is at 1 o'clock each day. It's also going to be a buffet up the back of the room. So, you don't need to leave the room at all. If you want to get a mattress and sleep here overnight, I'm sure that we could arrange that. So a few little things for this evening. The dinner's down by the edge of the lake at a place called the Jetty. Take a jacket. It could be a bit cool with the breeze over the lake. Just depends on what the wind is like there, really, with the over the water. But take a jacket just in case. If you haven't got a jacket, I've got a few extra jackets in my car, and so ask for one, and I'll get one out for you. On the Zoom, the speakers, as you come up with each speaker. So second speaker is Eric. If you could be ready with yours. Where's Eric hiding? There you are. Be ready on. So you'll connect to the Zoom call. The links for all of the Zoom calls are in the conference information sheet, that Google document you've all been hopefully looking at. And so join in that session and be ready to share your screen, but with your microphone off and your speakers off. Randy's doing the recording on his machine. So same for all the other speakers. Get set up on the Zoom. So we're live streaming. So we're live streaming now, and we've got people watching. Yeah, anyway, if each speaker gets ready before they come up and join the Zoom call. All right, so that's about it. So what we're going to do is give the first talk, and it just so happens that you're going to have to put up with me as the first speaker. So this is basically a systems update. I've given this each year during the dev conferences. Basically, it's a grab bag of all the things that are happening at the low levels in RGPilot, the systems level, what's happening with the ports to the various boards, etc. And of course, there's been an awful lot happening. So we had 5,500 patches merged in the last year. 2,300 pull requests were put through. That's a lot of activity, really intense. We have 2 calls a week where we have a whole bunch of developers to get together to discuss the latest PRs. And so clearly I'm not going to be covering all the changes in this. I'm just picking a few highlights and giving a couple of little demos of things that might be of interest to a technical audience like this. Oh, and it's great. The number of contributors we get each year is increasing. So 209 people have contributed to the main RGPilot repositories and documentation in the last year, which is fantastic to see. And thank you also to all the people who've contributed documentation. Massive thank you to Henry, our documentation lead, but also thank you to all the developers who contributed documentation for the changes that they've been making. Okay, so system highlights, sort of a bit of an overview of some of the things that have been happening in the last year. So we've gone all in with Lua. We've had Lua support for now a couple of years. And that's the Lua scripting language embedded inside the flight controller. Incredibly powerful system. So we now support Lua device drivers. And I'm going to demonstrate a couple of those. And Randy's going to demonstrate one later in his talk about gimbals. What this means is we can actually have device drivers for real devices running as Lua scripts inside the flight controller. And that's fantastically useful. You've got a stable release of RGPilot. You need a new EFI system, a proprietary CAN EFI, serial EFI, an I2C device. You can now write that solely as a Lua script, and it integrates into the rest of RGPilot, and really useful. 32 actuator support got merged. Been talking about it for a while. Many thanks to Pete Hall for pushing that through, getting the final pieces done. And so there are quite a few vehicles now flying with more than 16 actuators, and was really needed for the larger, more complex vehicles. Complete rework of our notch filtering system over the last year. Filtering is incredibly important. I'll be diving into that a bit more in a later slide. Remote ID support, very important with the FAA mandate in the US and now coming in other countries. Again, thank you to all the people who helped out with that, and a bit more detail again on a later slide. We now have parameter defaults in logs and Mavlink. Again, I'll talk about that a bit later. flashing the firmware from micro SD. So you can now actually upload a firmware to a vehicle using Mavlink FTP, and then you can ask it to reboot and flash that firmware. Great for swarms of vehicles or remote access vehicles where you can't get a USB cable in. Incredibly useful feature. Many thanks to Peter Barker for arranging that. We have a new support system, support.rgpilot.org, and I'll be demonstrating that during this talk, if the demo works. And finally, Citylon hardware improvements. If you haven't used Citylon hardware, it's worth investigating. It means you can run the physics simulator directly within the flight controller. That was first introduced last year, but it's been greatly improved. So you can do quad planes and rovers and all sorts of other vehicles. And it means you can have a swarm of vehicles and have them flying the simulator, connecting just with a low bandwidth radio link, like an SIK or RFD 900, and fly the simulator. And the simulation physics engine is actually running directly on the flight controller. We've got enough CPU power on the H7 flight controllers that is practical. All right, so that's sort of an overview. By the way, feel free to ask questions while I'm going along. Just raise your hand or shout out, and very happy to address questions. And if that means we don't get to some slide, that's absolutely fine. Okay, so support.rgpilot.org. So we have this new support system. It's documented by just going to support.rgpilot.org with your web browser. And it's incredibly useful for the partner support team, but it can also be used by partners supporting their own users. And basically this system allows us to ask a user from wherever they are in the world to forward their Mavlink. Now, we've had Mavlink forwarding for years. It's been possible, but it's been difficult and it hasn't been secure. So now we've made it secure using Mavlink 2 signing, and it's available. So any partner can request a support.rgpilot.org ID, and then there's documentation on how you can then support your users directly, get your end users to forward their telemetry link, and you then get your ground station connected to their vehicle wherever it is in the world. And neither the end user nor the support engineer has to have a public IP address. You can both be behind IP masqueraded, natted internet links. You only need outgoing UDP, which makes it very, very easy anywhere in the world. So I was going to give a quick demo of that. So here I have a vehicle here flying. I'm going to arm this vehicle, get it to take off. So what I've got is Mission Planner running on a VM here, and it's flying this vehicle. And then I'm pretending to be the end user here, and I need support. So we go to Setup and Advanced, and you'll see this little button, Support Proxy. You just click the Support Proxy, and it defaults to support.rgpilot.org. I was already connected, so I'll tell it to stop. And I say, connect to the support ID. The support engineer will tell you what ID they are using. So I'm just going to say 10001, which is my support engineer ID, and I go connect. And so then what I can do is go into my MAV support like that. So I am now the support engineer, and I am now receiving that telemetry, and I happen to be using MAV proxy. I could be using Mission Planner to receive that. And that means I have full access telemetry. All of those packets are actually going via a cloud server in the United States. So out from my machine via that cloud server and back to here. And it's almost got the parameters down. It's taking a little bit of time. It's not a particularly fast link. And then once it's got that, I'll be able to I can do something like get the waypoints up here, and that'll get the waypoints displayed on the map. And I've got the ability to provide advice or tuning support to the people remotely. So incredibly powerful system, very useful, available to any partner or any dev team member as a support engineer. So I'll just stop that. and you just press the stop button. You've got this little support pop-up box in Mission Planner, and you press stop, and it's now stopped forwarding, and so it's no longer sending to that support engineer. All right, let's go back here again. So that's our support system. Yep. They can. So they need, I'm sorry, there was a question. Thank you, Josh, for can the support engineer make changes on the vehicle, change mode, change parameters? They can. The recommendation is the support engineer doesn't without talking to the user and explaining. So the way I always operate it is I'm on the phone to the user. I'm on a audio call of some sort, either a internet type link or a real phone call. And so most of the time, the support is actually done when the vehicle's on the ground in pre-flight, but I have done it with some vehicles where it's flying, and before I make every change, I talk into the pilot and say, I am going to raise that roll gain, I am going to do this, and I wait for them to acknowledge, yes, you're going to change that, then you do it. It's very important to have that communication, that audio communication channel. Obviously, if it's a simulator at the other end, it's less critical. And it is actually very useful doing this with the simulator. I have helped people in many times sort out issues, for example, with real flight simulation, where they've got some issue in the vehicle, teaching them how to tune the vehicle, and I get them to forward the telemetry from the simulator to me, and then I can demonstrate the process of tuning a vehicle. It's a great way to teach. Any other questions about the support system? Yep. So it uses Mavlink 2 signing. So the way it works is that it's secure in the sense that without knowing the signing key of the support engineer, and every support engineer has their own signing key, without knowing that signing key, you cannot see any data from the user's vehicle, and you cannot send anything to the user's vehicle, right? So it's secure in that sense. It will only accept stuff with that signing key. But the packets are not encrypted, right? So if you are in a situation where knowledge of where you're flying must not leak out of the vehicle, this is not the right technology for you. In that case, you need a VPN or similar technology because the packets are flowing in the clear, but it's using the cryptographic signing of the packets to ensure that only somebody with the signing key is able to either receive the telemetry from the vehicle or control the vehicle. Now, the end user does not get the signing key. It's only the support engineer knows the signing key. It would be horribly insecure to tell all of the end users what the signing key is. And so individual support engineers, there's a page in our documentation that tells the support engineers how to change their signing key if they think it might have been compromised. Any more questions about the support system? Yep.
Forwarding of video as well?
It only does Mavlink. If you want to do video, you need to do it via some other system. Commonly, people use like a Zoom call or a Google call or Facebook, whatever you like. It doesn't do that. It's just low bandwidth Mavlink. It's also low latency Mavlink. The problem with the types of video links, etc., is you can get enormous lags, and you really want control to be very low latency. And that's why we structured in this way. Any other questions about the support system? Okay, so next topic, new parameter default system. And this is another one that seems quite trivial, but is in fact incredibly useful. And kudos to Pete Hall. We worked very closely together on getting this implemented. So what this is that ArduPilot now tracks what the default value is for every parameter. And it sends that when you do an FTP-based parameter download, it is sent to the ground station. And in every log file, every parameter that is logged in the log file gets both the current value and the default value. Now, the reason that's so important is it means that a support engineer can, on a log file, instantly go, what has changed? What parameters have changed from the defaults? What have they done on this vehicle? Because the defaults for different vehicles are different, depending on the type of flight controller, the exact firmware version, the type of vehicle you've got loaded, and the defaults actually are changed by other parameters. A good example is, say you've got a quad plane and you set it up as a tail sitter. The default gains on your VTOL controllers on a tail sitter are different from the default gains on a SLT type quad plane. And the parameter system knows that. And if you ask what has changed and it's set up as a tail sitter, it tells you what you've changed from the tail sitter defaults. So in other words, the definition of what the default is a little bit subtle. And I've put it there. The default value is the value you would have if that parameter had never been set, but all of the other parameters are at their current value. Right? So it's not the defaults if you wipe the board. For many of the parameters it is, but for many others it isn't, because there's a chaining effect where you change one parameter, it changes the defaults of the others. One of the obvious ones is an enable. If you do enable quad plane support with QEnable, then all of the quad plane parameters appear. They're not even in the defaults. They're not there at all if it's not enabled. So it's a little bit subtle there, but it's useful in the sense that when you're reviewing the parameters, you can see exactly what the user has changed. It's also live. So when I was on this link here, so I'm connected on a board here, and I can go param diff, and what that is showing me, this is the MAV proxy interface. It is available in Mission Planner as well. When I go param diff on this particular flight controller, it is showing me all of the current values of the parameters and the default value for every parameter. And I can do that with wildcard patterns like this. Show me only the changes, so maybe QA star. They're all the changes that I've made on this particular board for just the QA parameters. And you can see the first column is the current, the second column is the defaults. In Mission Planner's parameter interface, there's a little button, little tick box in the bottom right corner. And that shows you, that does the same thing and only shows you the ones that have changed from the default. So it's a very subtle change, but it's incredibly powerful for diagnosing problems, and it's one of the most helpful things for a support engineer. Any questions about that at all? Yep. That changes the defaults. Yeah. Yeah, that's right. So that makes that more useful. All right, Lua device drivers. I mentioned this at the start. Yep. Yep. You need to use the defaults.palm embedded to change the default. Tom, question? Okay, so up the back asked, sorry, it's too dim up there. I can't actually see who it is. Ah, right, James. Okay, so asked whether you can change what the default is, and you use the defaults.palm file, which you embed in ROMFS, and there's documentation on the wiki how to change the defaults for your particular build. Or yeah, that's right, or in the APJ tool. Okay, Lua device drivers. So Lua scripting, incredibly powerful system, but up till this year, we couldn't actually write device drivers in Lua. We now can. So we now have support for EFI, so electronic fuel injection device drivers, gimbal device drivers, mount device drivers, and rangefinder device drivers in Lua is pending. Reshab's been working on that, and we should get it in soon. Reshab? It's there, it's merged. Ah, fantastic. Thank you, Reshab. I missed the merge. So fantastic. So that's now merged as well. So slides are already out of date. So this is particularly powerful for people who want to run the stable release, but add a new device that wasn't supported in a stable release. So for example, a new EFI system or a new rangefinder, then you can write a device driver, or the partner support engineers can help you write a device driver. and add support for that new device. So it copes with rapidly devolving vendor APIs, supports serial CAN or I2C devices. So there's examples that emerge at the moment. There's the HFE and SkyPower EFI drivers, the DJI RS2 CAN gimbal driver from Randy, and the View Pro serial gimbal driver. So I'll give a bit of a demonstration of what that looks like in just a second when I move on to the next section, which is Lua driver testing. So Lua, we're sort of really stretching our wings with Lua over the last year. And one of the things that we've started to do is use Lua to drive hardware testing. And so we can actually create simulated devices in Lua, and then we can test the device driver, which might be a C++ device driver or a Lua device driver, using a Lua simulator of the device. So what I've got here is a demonstration of that. There is a Cube Orange here with its case off, and I have a CAN cable here connected in a rather unusual way. I have a CAN cable going between CAN 1 and CAN 2, loopback. Right, so all the packets going out on CAN 2 go in on CAN 1, all the ones that go out on CAN 1 come in on CAN 2, right? So it's talking to itself on CAN. So then what I've got is I've got a Lua device driver for the SkyPower EFI system. And that is, you can see here that these are the parameters for that, EFI SkyPower enable, because of course Lua scripts can create parameters. And it can add parameters into existing subparts of the parameter tree. So this particular one is adding parameters under the EFI section of the parameter tree, adding the SP for SkyPower, enable, generator function, logging, rates, etc. Okay, so what I'm going to do now is demonstrate that. So running here, if I do this, then you'll see that I'm getting RPM. So this little board here is getting this sinusoidal RPM, right? And that is because I've got written here, I've got a little Lua script. If I list the Lua scripts on this board, so FTP list APM scripts, then you'll see that there is an EFI tester.lua, which is a Lua script that simulates multiple types of EFI systems. So this particular Lua script will do the SkyPower and HFE simulation. It creates CAN packets in the Lua script that mimic the behavior of the real SkyPower EFI system. And then I've got the EFI SkyPower device driver running on the other CAN port, and it's receiving those packets from the other side across between the two CAN ports. And that is then feeding into our EFI system. I have EFI type set to scripting, and I've now got the tester just produces a sinusoidal RPM and temperatures and pressures and all those things. I'm just showing the RPM, and that then appears on the board. So that means we can simulate devices in Lua and test our device drivers. And this can be used for testing either our C++ device drivers or our Lua device drivers. And it's a very, very powerful technique. Any questions about that at all? Yes, Richard. Yep.
This question comes up again and again. That is it safe enough to have a critical component running in Lua?
Right.
When my Lua script time between and I be left with no sensor at all.
Right. So Rishab's asking, is it safe to run Lua device drivers? I believe it is. You've got to write, however, the device driver carefully. So you have to make sure that it handles all of the errors. We normally also write the device driver in such a way that, and just going to get rid of my silly email that keeps coming up here. And I have no idea where it's coming from. So somewhere here. All right. Okay. Let me kill that off. All right. So when we write these device drivers, if I look in drivers, for example, and EFI Sky Power, we run this thing called a protected wrapper. So if the Lua script, that's this part at the end here, if the Lua script died for whatever reason, it will automatically restart. So in some ways, it's safer. If you were to write a C++ driver and that driver were to die, a null pointer exception or something like that, then you will crash. That will bring down the whole vehicle. With a Lua-based device driver, it can restart just that device driver because of the way our Lua is sandboxed. So in that sense, it's safer. There is a risk of running out of RAM in Lua. So you have to make sure that you have plenty of memory given to the Lua script. So it's really only viable on H7 microcontrollers where you've got a megabyte of RAM and you can afford to be generous in the memory given to your Lua script to make sure it's not going to run out. And you need to write the device driver in a way that it doesn't continuously allocate objects, just like in C++. If you do a lot of dynamic allocation in your C++, then there is a risk that you'll run out of memory. If you do that in the Lua will shut down. That's better than crashing the board, but it will stop that device, although it will also restart again because of the protected wrapper. Okay, any other questions? Yep.
Yeah, does it work with CAN devices only or can it be supported?
CAN, serial I2C. Yep. We could do SPI as well. There's no reason why we couldn't do SPI, but the ones that we've had use cases for so far are CAN, serial, and I2C. It will support Ethernet. There's a very exciting talk coming up from Tom and Sid, where they're going to be talking about the Ethernet support in RGPilot. So once we've got that merged in, then all of these types of things will be on TCP/IP as well. So UDP, etc. All right. Yep. Yes, they do. So when the question was, do the parameters you create with a Lua script interface into our default system? Yes, they also interface into our documentation system now, which means you'll notice that if the developer has been bothered to document the parameters properly, and not all the scripts are fully documented yet, then all of the documentation for the Lua script parameters will appear in your ground station's parameter interface, and the default values are correctly recorded in. So it'll actually show you what changes you've got from the default values of the parameters created in your Lua script.
Everything works for the drivers, et cetera, that have been posted into RGPilot's main repo, right?
For the documentation, for the defaults, it works for all of them. But for so Randy's point was that it only works for the ones that have been put into our main repo. That's true for the documentation because we parse the Lua scripts to get the documentation, which we feed up to our firmware server, which is where you get the parameter documentation. So that should encourage you to submit your scripts back for inclusion. But so the defaults work for any Lua script. The parameter documentation only works for the ones that have been submitted back to our firmware server. Any questions about that at all? Any more? Yep, that's it. Sorry, John.
How do parameters defined in Lua get their index for storage?
So the way it works is our original top level tree was an 8-bit tree, 8-bit index at the top level. And then we have 3 sub levels of 6 bits each, right? So we have 8 plus 6 plus 6 plus 6 bits forming a level 4 tree of parameters. The top level 8-bit, we expanded a couple of years back to 9 bits. There was one spare bit and we were able to leverage that bit, which means the top level is now 512, but we're only using 260 odd of it. So what we did was we reserved a couple of hundred range of top level for use by Lua scripts. And you'll notice that up the top here, that when I create the table, parameter table, you've got this parameter table key, that line 36 there. I don't know whether you can read that very well, but that when you create the parameter table, you give it that key and that anchors it at the top level, our parameter tree, and you can go down from there. And so it's stored exactly the same as our standard parameters, but they can be created dynamically, whereas our normal C++ doesn't yet take advantage of dynamic parameter creation. Although there is no reason why our C++ code can't do dynamic parameter creation as well. The APIs are there. It's just so far we've only been using it for Lua scripts. Any more questions about that at all? All right, let's go back on with the show. So the next thing I was going to show you, and slightly unusual in that showing off bugs. So there's been a number of bugs this year that we've fixed, and there was a particularly important one. I would classify it as perhaps the worst bug of the year. And so this bug was the bidirectional D-shot RAP32 bug. And it affected people using bidirectional D-shot, which is already fairly unusual. That's not just D-shot, but D-shot with bidirectional transfers for getting RPM, typically used on small racing quads, but is used on some larger vehicles. And at the 71-minute mark, which is the wrap of a 32-bit microseconds, we had a bug where there was approximately a 1 in 3 chance of your motor output stopping. Now that's disastrous, losing motors in flight. So this was a major bug. But what I wanted to show you in this talk is some techniques we used to A, find and fix the bug, but B, using Lua to do hardware soak testing, right? Because once we fixed this bug, it was a probabilistic and it took 71 minutes to reproduce. We wanted to do thousands and thousands of cycles of testing, right? Which is not very practical. So with Lua, we can do that. Let me show you. So it's obviously fixed. All the stable releases have been fixed for this bug in the latest stable. So the diagnosis test technique is somewhat similar to the CAN one. You'll notice again an unusual configuration of this board, right? You'll notice that I have this little cable cross-connected between auxiliary 1 and auxiliary 6 on this board. It's a little DuPont lead going between auxiliary 1 signal and auxiliary 6 signal. That means the board can read its own signal, right? And it can read not just say, are we trying to send a signal, but by actually looping it back into another input pin, we can confirm we are actually getting the signal. Because when this bug bit, ArduPilot was completely oblivious to it. It thought it was sending signal, but there was a very low level thing going on with the DMA stream sources in the STM32H7, only affected H7, that stopped the signal getting out when the bug bit. So we loop it back like that, and then we have a Lua script. And I'll just turn on the Lua script and show you what it does. So what I'm going to do is I'm going to enable this Lua script, and you'll actually see the board rebooting. My apologies there. Just let me bring up my MavProxy console window. All right. So what this Lua script is doing, and I'll show you the actual script in a section. I'll just explain the theory. So the Lua script, we added a feature to ArduPilot that allows you to boot ArduPilot at a time other than 0, right? So we can boot ArduPilot 30 seconds before the wrap. Okay, so it starts up at 70.5 minutes, just before the critical time. All right, so that means that the Lua script, when it starts up, it counts down to the wrap point, and it is reading that pin that's looped back and watching the VD shot signal and checking, is it getting VD shot coming out of that pin? And so it confirms the little script, if I show it here. So this is our wrap script, wrap test. What this one does is it counts the transitions on the pin to determine that it's VD shot. And it first of all counts down to the wrap point. And before the wrap point, it first of all confirms I am getting BD shot, I'm getting the D shot signal. Then after the wrap point, it checks it's still getting the D shot signal. And there's three possible answers that it can get. A fail answer, an error answer is where it doesn't get the D shot in the first 30 seconds before the wrap. A pass is getting D shot both before and after the wrap, and a fail is getting it before the wrap, but not after the wrap. And so what it does is this little screen you've got coming up here, which is probably a bit hard to read. This is it looking for the D shot changes, and then it uses Lua parameters. So if I show the Lua parameters I've got here, this script creates a number of parameters, which is so it's got the count of the number of tests that I've done, and it's got whether it's enabled, how many errors I've had, how many fails I've had, and how many passes I've got, right? And which pin it's looking on. And so that's able, so now when it's then got past the wrap point, a few seconds past the wrap point, the Lua script force disarms and reboots, right? Reboots the board and it all starts again. And the state is stored in these Lua parameters. That means it's entirely standalone. You put it on the bench with that cable looped back, leave it overnight, you get a new test run every 45 seconds, right? With the boot time of about 15 seconds, which means you can do thousands and thousands of tests in a night. You have multiple boards in parallel on your bench. You can be very sure that if you've got, we did actually, Andy and I working on it together, Andy Piper in the UK, we got several thousand tests overnight before we pushed out the fix the next morning. And it gives us a way to be very, very confident. We also, of course, were looking with logic analyzers and looking at that type of level for signal integrity. But this was the bulk testing over a long period of time. So it's a very, very powerful test technique that I'd highly recommend you look into. You can do an awful lot with Lua script testing. So I'll just turn that off again so there's an enable parameter in the script. I'll turn it off so it stops rebooting my board here for more demonstrations. All right, so back here again. Any questions on that before we move on?
Could we find the root cause why it was happening?
Yes, we found the root cause. So the question was, did we find the root cause? Was there something else? Yes, the root cause was the H7 shares the same DMA channel for the outgoing D shot and the incoming BD shot. But one is called the UP channel, the other is called the IC channel. It's a different source to the DMA. So one is being generated by the UP timer for an outgoing pulse stream. The other is the IC input capture timer coming in from the edges on the timer back. And what happened was at the wrap point, it got a momentary timeout, and that timeout logic in the code did not reset the DMA source back to the correct one. So it was left on the input capture for the next D shot output. When that happened, the next D shot output also timed out. So it had the same bug again and again and again, 1,000 times a second. And so it continuously just didn't put it out, didn't put the output. So it was actually a one-line fix, although what we did was we made a larger change. We switched to 64-bit microseconds in all of that code as a belt and braces approach to be absolutely certain that all those classes of bug are gone. But it actually only needed a one-line change, which is at the start of the D shot output, to set the DMA source every time we start the D shot to guarantee that it's using the UP source from the timer, not the IC input capture. So we could have done it with a one-line fix, but we did the belt and braces fix to ensure that there wasn't anything else lurking there. Is that, yep. Any other questions at all? Okay, so moving on, filtering improvements. So filtering is incredibly important. After you do your thrust linearization on a VTOL vehicle, your next stop should be your filtering, getting the filtering right, then move on to the tuning. So many people do it the wrong way around. So get your filtering right. And our filtering over the last year has become much, much more flexible. We used to have just one harmonic notch filter. We now have two, which means you can set up one on, for example, the EFI RPM for an internal combustion motor, and the second on your VTOL motors. You could have one on ESC feedback, another one on a real-time FFT. So you can set incredibly sophisticated filtering strategies. Then within each of those filters, you've got a lot more flexibility with new notch types. So what I'm going to do briefly is show you our little filter tool that some of you may not have seen before. And so this is our filter analysis tool, which is at firmware.rgpilot.org tools filter tool. And what this tool does is you can set up all of the RGPilot parameters just the way you have it on the real vehicle. And you can also input what the throttle is for a throttle-based filter, or if it's an RPM-based filter, you can put in what the engine RPM is, and it runs our code and analyzes the filter, giving you the amplitude, the magnitude, and the phase at each point, at each frequency. So the frequency is on the x-axis. And what you're looking for is where you cross over around 90 degrees, where you start getting real trouble, at what frequency you start crossing over. Too many people put in really aggressive filters that get rid of all of the noise and make it nice and smooth, but it's phase lagged. It slows the signal down, and phase lag is what causes your oscillations. Phase lag is the killer. So you really want to make sure that you have your filters set up, and that's the point of using a notch filter, that it doesn't disturb the phase lag nearly as much at the lower frequencies. But it also allows you to play around with our new options. So I'll just go and set this as our original standard notch filter, and we can see there's a notch filter, right? We're seeing two harmonics there. You can see what's happening to the phase. You can see the magnitude there, the dip happening at the particular frequency we've got set up there. So that frequency is 45 Hertz, because I've got this set up at the moment as a 45 Hertz frequency, and we're at the hover throttle, which it'll shift with the hover throttle. Now, that single notch filter is quite narrow. So some time ago, last year, we introduced the double notch. And if I go and turn on the double notch here with our notch options, there's double notch. And watch what happens when I calculate. I've now got a double notch like that, and then up and then down. So it's two notches next to each other. So what that's done is it's made it wider here, but right at the center frequency, you're not getting as much attenuation, right? So your filter is less effective at the exact frequency you want it, right? But it is wider. And for a long time, people were happy with the double notch. It did do its job, but there was this weakness that the attenuation wasn't as good right at the frequency you care about. So we've now got a go up to 16, and that will enable the triple notch. And if I recalculate that, that is now 3 notch filters next to each other, right? Which has now made it wider, but you're not getting that, you're still getting good attenuation right on the frequency that you want. So significantly better. So what this allows you to do is, often this is done by the partner support people analyzing your logs. This is the tool we use, but it's worth playing with the options yourself and understanding them, particularly looking at the phase lag. So for example, let's have an example here. So if I go to say, I don't know, 20 Hertz here, and I look at the phase lag I've got 24 degrees phase lag at around 20 Hertz. If I start putting in the gyro filter, and I put, say, a 15 Hertz gyro filter, which I commonly see in people's logs, quite low pass filters, and they put them in there because it reduces the noise. And people think that less noise is going to be better. Let's see what happens when I put in that 15 Hertz gyro filter and calculate. What that's done is that has attenuated more, but now if we look at 20 Hertz here, we've now got, what have we got, 140 odd degrees of phase lag. that basically that low pass filter, 15 hertz, beautifully smooth signal, but the signal is way behind in time at the frequencies we care about. And that gives you oscillation, right? So you've really got to watch your phase lag very carefully and craft your filters to fit the vehicle. There isn't one set of filters for everyone. Every vehicle is different. And this is the tool you can use to do that analysis and to understand what's happening to your phase lag. You can also, of course, add in your second filter. So I'm going to add in here a second notch filter. I'm going to make it an RPM filter from an EFI engine. And I'm going to set the RPM coming from that engine as 2300 there. And then I'm going to calculate. And what you'll see is here's the notch that we've got from that RPM filter coming in there, right? As well as the one from our vertical throttle. And we could then adjust, for example, we could make that, say, like 18 to do a triple notch, 16 for a triple notch, and calculate that. And we'll see then the effect of that triple notch coming in there and what that's doing. Incredibly powerful, and many thanks to the work by Pete and Matt and others on this tool. Very, very useful to analyzing what's going on your filtering. If you haven't looked into the filtering in your vehicle, you should. All right. Any questions on that before we move on?
There's a question online, Trish.
Yep, James.
Tim, the plane man,
Question from Tim.
which is what is notch filtering?
Okay, notch filtering. A low pass filter, like it sounds, is it removes noise, smooths the signal starting at a low frequencies, and there's a notional cutoff frequency. So in other words, it just moves down all the, so that it only passes the low frequencies through and chops off the high frequencies. A notch filter, you can see these little notches. It's called a notch filter because it looks like somebody's taken an axe to your signal, and it removes the noise just at the frequencies where it's being generated, at your propeller frequency, at your engine frequencies. And so many vehicles that run Archipilot actually have lots of notch filters. They've got an octa-quad aircraft with ESC RPM feedback, that's 8 RPM signals. Then you might have a triple notch, that's 24 notch filters. Then you have 3 harmonics, that's 72 notch filters being applied to your vehicle. And if you do that, you want each of those notches to be very narrow, because if you put 72 broad notch filters, there'd be too much phase lag. And that's where you use this tool to analyze that setup. And you can actually set up an octa-quad ESC feedback in this tool and see exactly what the impact on the phase lag is. But it allows you to remove enormous amounts of noise. And then you can have your low pass filter much less aggressive, which means your phase lag gets much less and your vehicle flies better. All right, any final questions on that? Yep. Yes, indeed. That's the advanced topic here, is that further down the page, which I didn't go into, you can actually set your PIDs, your roll, pitch, and your PIDs, and analyze the magnitude and phase going through your PID. So you can see, for example, the phase recovery that you get with a D term. That's why you want D term, because D term gives you phase recovery. And as you raise your D term, you'll actually see the phase lag decreasing. And as you add in I term, you'll see phase lag increasing. So you can actually analyze the complete system all the way from the sensor out to the actuator using this tool. Incredibly powerful. Thanks, Paul. Yep. It's vehicle dependent. Depends on the control bandwidth of the vehicle. Rule of thumb, in like a quad plane, you should be aiming to get your gyro filter up to maybe 25 or 30 hertz, but it's very vehicle dependent. And sometimes you just have to have a low pass filter in there. Sometimes you need a very, very narrow notch around an RPM from a motor. I can't tell you what the minimum would be because it's so vehicle dependent. There are RG Pilot vehicles, some of them weigh a ton, some of them weigh 200 grams. And the answer is very different for different types of vehicles.
In general, the bigger the vehicle, the lower.
Yeah.
the frequency.
That's right. The bigger the vehicle, the control bandwidth is lower. So the lower the frequencies you can go to and still have good control. All right, so let's keep going. And back to slideshow. Okay, remote ID. Big thing in the last year, getting remote ID up. Huge number of people helped. Jeff and Roll, Michael, David, Rob, Craig, Steve, all helped into enormous effort when the FAA said, okay, it's really going ahead. The legal challenges were unsuccessful. We have to have remote ID support. So RG Pilot now has really good remote ID support. We have a new firmware, the RG Remote ID, and other vendors have brought out their own remote ID solutions. The Q Pilot one, very notable, many of you might be using. It all integrates into the open remote ID support inside RG Pilot. That incorporated also Secure Boot. First time we've done Secure Boot in RG Pilot, and that was required in some circumstances, read the wiki, for meeting the FAA obligations on tamper resistance. Ground station support, Mission Planner, QGC, and Map Proxy all supporting remote ID, Open Drone ID. So that was a huge effort over the last year. Custom firmware server, we had this last year, but it's been enormously improved. Shiv, are you here? Yeah, so Shiv jumped in to help in this and has enormously improved this custom firmware server over the last year. We now, in the firmware server, we load the default options from the standard build. So if you ask on the custom build server to build plain cube orange, it will preload all of the options you would get with the standard build for that target and that board. And then you then adjust the ones that you want. It supports now both the stable and master branches. So that was contribution both from Michelle, thank you, and from Shiv. Fantastic feature. We also now have 224 selected build options. So I'll briefly go across and show you. This is our custom build server here. And if I go and add a build, then it's fetching all of the features. And so we can now choose, I want to do a copter latest, and I want to do it on, say, a CUAV X7 board. It's now got all of the options are automatically populated for what you would get on the standard build. And then you can then say, I don't want the MS4525. I don't need the Riken power generator, but I do want the Intelligent Energy 2400 generator support. And you then go and generate that build, and it will build it for you and give you a RG Pilot build, an APJ file ready to load on your vehicle. Incredibly powerful tool. Many, many thanks. Original implementation from Will Piper, then Michelle and Shiv have done wonderful work on improving this. You really should be using our custom build server. So I won't bother for it to finish building there. It's in the queue. All right, so back again. And okay, so 4.4 is just about to go out. We can now do missions on the micro SD card. That means the old 500 waypoint limit is gone. You can do 4,367 mission items. If people want more than that, it's a fairly easy change for us to push it up far beyond that. But it starts getting fairly ridiculous in the management of your mission, but you can in fact go up. We could easily change it to be far beyond that if need be. So log disarmed for on battery only, useful for developers, so you're not having log disarmed all the time. Parawong ESC support, throttle gain boost for VTOL, a very nice feature from Andy Piper. Synthetic current battery monitor from Henry. For people without a current monitor, it can synthesize a current monitor. The Unicorn NMEA GPS, a really nice new GPS that Hollybro and CUAV are bringing out, both CAN and serial versions. with support for L5 and dual antenna moving baseline directly in a single GPS. Jump tag support is a wonderful feature from Tom, makes you to create really complex missions, but much easier to understand and much easier to use with Lua scripting. Very nice work from Tom. And of course, Simon hardware. 4.5, we've just moved to a new Shibios release as of yesterday. Ethernet support. The star of the systems update really is Tom and Sid's talk coming up about the Ethernet support. And ROS2 DDS support. Ryan Friedman, hand up. Ryan. So Ryan's done fantastic work pushing on along with Ash, the ROS2 DDS support, and he'll be talking about that later in the conference. Lots of improvements QSPI, and please remember, developers, keep your documentation up to date. And that is it. So just in time for finishing at the hour. Any final questions before we move on to the second talk? Okay, so we'll move on to the next talk now. So the second talk is Eric Maglio with the most amazing vehicle that he's built. And it is actually, you've got it set up there. So Eric, are you about ready to go? Okay, you come up here and plug in. Right, just grab a couple of things. There'll be a little bit of stuff as we're changing over here.
Are you doing just HDMI to the
Yep, just grab that HDMI. This is the HDMI cable. Just plug that in. It's all right. Make room. Right. Actually, I might go the other way with that webcam and get a second. Would you? I pop in there. So Peter, I'm going to start handing out extension boards and tower boards and so people, there are more extension boards and power boards up the back. So if you're power deprived, then please go and just grab one and then chain it onto the existing one. So there's more up the back there that Peter has organised. Things okay out there, Rick?
Yeah, do you also need me to share to the Zoom call or just the HDMI?
It would be good if you would be on the Zoom call. Have you got the link?
Yeah, I'm on it.
And so are you sharing screen on that?
Oh, but I can do that now.
And let me just make sure you're a co-host. Okay, you're now a co-host, so you can now share screen on there. So share screen.
All right, how's that? Let me get it.
It's possible, but I'm not like to guarantee it.
Sorry? Oh, yeah. How could I compete? Looks like it. Yeah, that's fine. Perfect. Nice.
Recording ready. Thank you. Still recording. Still recording. I will. Yeah. Right. And maybe Louis saying that the camera is slightly slanted. Yes, view. All right. Down on the right if it's possible. If not, let's just keep going. That's better. That's great.
All right.
Over to you, Eric.
Okay, so I'm Eric Maglio, and the topic of my talk is the F-35B as a quad plane. This is a project I've been working on for a number of years. There's some other talented people all around the world that are working on similar projects, but the big differentiator with mine is that mine works. It flies the whole flight profile rather nicely, and it works because of ArduPilot. So I'll give an overview of the airplane in general, but I'll also go a little bit deeper into some of the customizations that I made to ArduPilot to fit this particular fairly unique configuration of aircraft. We had a good day at the flying field yesterday and the winds were low enough to sneak in a flight. But if you weren't able to see that, I've got a video clip here that I'm hoping to show. If the hotel Wi-Fi is permitting. There we go. This is there's not many aircraft where you can fit an entire flight into one slide of a presentation. This is one of those. I don't know if that's a feature, but it's worth doing at least. So really quick takeoff and transition into forward flight. It's consuming about 3,000 watts to get off the ground. So you really want to get into fixed wing mode where you're a little more efficient as quickly as you can and save some of that battery power for the landing. In the fixed wing flight, it's almost always in fly-by-wire A. I've got the bank angle limits turned up, of course, but it's pretty comfortable to fly in that mode. Checking some control responses too. And then back into the hover. This was the first flight of this particular model in this video. So I had the multi-rotor tuning done, or at least done to an extent where I could fly it, but that was the first real fixed wing flight without any change from some default tune. A retractable landing gear, of course. Quite a lot of yaw authority with the vector thrust in the tail. All right, so we'll dive right in here and just go into an overview of what this aircraft is. It is, of course, in real life, a VTOL capable jet fighter. That's vertical takeoff and landing. Most of the time you'll see it do short takeoffs with some roll, just because it can't really carry any payload if it's got enough energy to vertical lift. But the concept is the same. But naturally, all of aerospace engineering is a compromise, and when you're starting to get aircraft that do multiple different roles, you're just stacking compromises. Very inefficient, very low performance, but it's really cool. And because of that, it's worth building a model of for sure. Now, the configuration of the full-size aircraft, there's, of course, a turbofan fighter jet engine. There's a forward lift fan. That lift fan is 2 counter-rotating fans, and it's shafted to the main engine with a clutch. So there isn't a separate power plant for vertical lift, but the thrust from the lift fan can be varied a little bit with some inlet vanes, with some nozzle vanes, so that they can achieve pitch control that way. Roll control is done with roll posts in the wings. These are compressor bleed. So it's air that comes not from behind the fan, but behind a few stages of the compressor. That'll be important with how it translates to my approach in a bit. Now, if you squint, if you look at this closely enough, that's a quadcopter. It's a plus mode quadcopter. Where that compressor bleed comes into play is I've made the decision on my model to use fans for roll control. When you're bleeding from a compressor, that's high pressure air. It's low velocity air. So you can move that through ducts. You can make thrust with nozzles, and you don't lose a lot of energy that way. But when it comes from behind a fan, if I were to take some ducted exhaust behind the main fan here, that's lower pressure air and it's higher velocity, and it's really lossy. You're going to lose energy every time it goes through a bend or just based on viscosity from the walls of the ducting. And I had a couple of test aircraft where I could use that, but it just didn't provide enough authority for being outdoors, having all this surface area affected by wind. It wasn't the way to go. So the roll control with the motors is an interim step. I do plan to hide that a little bit better with still dedicated fans, but ducted elsewhere inside the aircraft. But that's how it was necessary to configure this to get it to fly. The next major step is the motor mixer, and it's a plus mode quadcopter, but it doesn't use variable torque for yaw, especially with two different sets of very different power plant. In fact, the roll thrusters are not contributing meaningfully to the total thrust of the vehicle. They're just there for roll. And so my first thought was to take the plus quadcopter frame and add the tilt servo code from tricopter, but that turned out not to be the right way to go. There's a lot of code necessary for the yaw tilt to work, and it was much easier to take the tricopter frame class and just add that fourth motor back. You don't even have to change the motor number because on a tricopter you have 1, 2, and 4. So in fact, it's possible to get this configuration to fly with not a lot of important features, but fly in general with 12 lines of code changed from stock ArduPilot. And that's a lot of my very early first hovers were that small of a change. I didn't even bother to rename the tricopter frame class that early. It was just tricopter with 12 lines of code added to it or changed. And then, of course, it's not really a yaw servo like a tricopter. It is a much more complicated arrangement of 3D printer parts. So I'll talk a little bit about the 3BSM. The acronym stands for 3 bearing swivel module. And I've had a couple of questions asking, is this how the F-35 really does the vectored thrust? And the answer is yes. This is largely a realistic configuration. The tilt range, the vector range is pretty close to the real aircraft. They are not using 3D printed plastic, but this design works well for this model. It has 48 bearings, it has 85 screws, and there's a 105-degree range of motion. So I can have thrust in the backwards direction for braking and for translating backwards. I, of course, can go all the way to 0 degrees of deflection for forward flight. And then one of the three, the section there that's planar, the planar ring, that will move for yaw control. This originally was powered by some gear motors with encoders, and that worked for a little bit before generating some reliability issues, and then I landed on the CAN servos from Hitech. With servos, you get a little bit more quality control on the motor itself and the gear train to a lesser extent as well, and that was really important for this. The gear motors had a failure mode where you'd burn out brushes and you'd lose torque without too much warning, so you'd run into situations where you're flying and suddenly your thrust vector becomes fixed, and that's not fun. To drive the CAN servos, there's a custom control board running custom software. I'll talk about that in a little bit regarding why that's necessary. But the main takeaway is that it just uses simple PWM inputs. As far as ArduPilot is concerned, this is a tilt servo and a yaw servo. And all of the complexity of the nozzle motion and the trigonometry to do the circular movements of the rings, that's all abstracted by that controller board. So here's what I mentioned about that custom software. The Hitech CAN servos are unique in that they don't have any stops, so they can rotate both in continuous revolution mode and have encoder feedback for position control. And in the proprietary CAN protocol, there is a message for specifying integer numbers of rotations and encoder positions so that the servo can rotate anywhere from 0 to 32,000 continuous revolutions with full position control everywhere in between with one CAN message. But that's only supported in the proprietary, the CAN 2.0 protocol. It's not yet in drone CAN, and that's what forced me to use a custom board in between, just doing that abstraction between those PWM tilt and yaw servo inputs and the CAN 2.0 message. And that allows me to achieve that. I don't need 32,000 rotations, but the two main off-axis rings in the nozzle, the way that they're geared, need about 4 full rotations to accomplish the full range of the thrust vector. So it'd be really nice to eliminate the need for that. I haven't found a way to do that just yet. The custom solution works. So I'm sticking with that for now. I made a neat little configuration tool for setting up things like the servo speed, homing procedures, PWM input ranges, just some parameters that are specific to that nozzle controller. But if I can move this functionality to Lua scripting or something similar, then I can just delete this extra hardware, delete the extra software, save some weight and complexity. And that's on the table for next steps for this. There's a couple of ways to do that too. One might be supporting the arbitrary CAN protocol that the high-tech servos support. Another might be supporting arbitrary CAN messages in Lua that aren't necessarily drone CAN. Or maybe even a firmware change to the servos themselves that would allow the -1 to 1 abstracted rotation range to actually be multiple rotations. And then you'd configure the actual travel limits that you wanted in the servo and not in the flight controller. So there's a few ways to do that. Not sure where that'll head, but probably one of those. So next, I'll go into some of the airframe development steps that I took. This was very iterative. I had a lot of models that I built, a lot of stepping stones in between, things like that. The first model was just essentially a quadcopter with a foam airframe around it. I couldn't transition. It didn't have any control surfaces. It couldn't even tilt the motors. But this was what I used to test my changes to the tricopter frame class. And then eventually when it became my own frame class with the 4 quadcopter layout motors, but with vectoring for yaw tilt instead of changes differential torque. The next step was to actually build that 3-bearing swivel module, use ducted fans, and then assemble that on a frame that I could use to test the power system as a whole. And that's where a lot of the iterations on the 3BSM happened, where I figured out that I needed to go from the gear motors to the servos for more reliability. And then this is also where I developed some code to change how the vehicle translates back and forth when it's hovering. It did actually run quad plane, so you could flip into fly-by-wire and it would transition and it would not go very well without the wings. Yes, so that was next. I slapped some wings on that frame, just foam board wings around the wooden spars, so that I could do transitions, forward flight. Of course, there's nothing new in the forward flight. It's just, it's a rather draggy aircraft. Just tuned it in fly-by-wire and dealt with it. And then it spent, I think, about a year, maybe more than a year in that configuration, because really, aside from the shape of the airframe, that has all of the functionality that it needs to have for this project. And then lastly, when that was flying reliably and I was fairly confident it wouldn't crash, I integrated everything into a cooler looking airframe that was more recognizable as an F-35. And that way I didn't have to explain to people why this doesn't look like a fighter jet. So that's the iterations that I went through. In general, of course, this one probably crashed 2 or 3 times. This one crashed 2 or 3 times. So there were, permutations in between, but that's the general overview. There's also real flight models. I had CAD for both of those aircraft configurations, of course. So I was able to get those into a mesh format that I could ingest into real flight. And then, of course, ArduPilot running CITL, even with my custom branches, can fly these aircraft in the simulator. And very realistically, in fact, a lot of the handling and the tuning is pretty close between the real flight models and the physical ones. I spent a lot of time trying to get the mass properties in the real flight model editor just right. So this was a really good way to validate code changes and scripts. I'm not really a software developer in general, so a lot of times when I was making changes to the code, I needed the extra confidence from testing in the simulator in order to make sure that I haven't broken anything important. They're also much easier to repair than the real models. Like bashing the spacebar hasn't managed to ever put this thing back together. So that's nice for sure. It also comes in travel size. So you've noticed this model is not necessarily the same as that first video that I showed and some of the pictures. This is a scaled down version, and you can see the size difference between the two models here. 70mm ducted fans instead of 90mm ducted fans. And this version exists pretty much only for this type of event, where I can pack it in a case and bring it somewhere, show it off, talk about it, that sort of thing. It's pretty much the same design. Almost all of it is just directly scaled down, and then the removable surfaces are added so that it's easier to travel with. Here's a few more details about the airframe. Even though it's a step above that test bed with the wing strapped on it, it's still stand by.
We're still getting it through.
Okay, might be a cabling issue.
Yeah.
It's still designed to be a pretty simple airframe. It's just foam board. Is it over there?
Everything at the wall, thanks to the problem.
Sorry.
Good now, right?
Okay. You guys can edit that out before it goes into the recording. We'll fix it in post. Yeah, so it's foam board and some carbon fiber and some tape. It's not good.
Tends to be the one against the wall, it's a bit loose.
All right, nobody breathe for the next 20 minutes. So it's flat foam pieces. It's got carbon fiber spars. These are the structural elements that interface the removable wings as well. So the wing panels will have a tube that inserts into this square spar. And then all of the important bits, motor mounts, landing gear mounts, also clamp to those carbon tubes that run the length of the fuselage. What to do about that? It's got a smaller 3BSM, printed from lightweight PLA instead of regular PLA. Fewer bearings and fasteners. Just gonna sit over here and see if I can. Is there another way we can project to the projector? Can we
I mean, that actually bar.
just HDMI?
Yeah, probably a new cable.
Okay. Yeah, and then all of the white components that you see, the round parts of the fuselage, mounts for the vertical tail, those are also lightweight PLA. So it's an interesting mix of material that keeps it lightweight, simple to build, easy to repair, and then of course, easy to transport. And I had a custom case made so that I could bring it on trips and it would endure the rigors of baggage handlers. So now I'll dive into one of the issues that needed some customization to solve, and that's body tilt. So if you've built a quad plane before, if you're in a Q mode, if you're hovering and you command a forward or backwards translation, you're going to get pitch upward or downward of the vehicle, which is great for multi-rotors, but for a quad plane, when you're driving a big wing around, and that wing is subject to aerodynamic forces, now you can create lots of downforce, you can create side forces if you're pitching that wing around. And if you're in a power constrained aircraft that has tiny ducted fans, that can really make or break whether you can fly reasonably well. V forward gain does not help this. It doesn't fully inhibit the ability of the aircraft to pitch. It just assists with the forward velocity demand. So here's a vehicle in real flight, just showing how difficult it is to translate back and forth if you allow the vehicle to tilt. And even in the simulated environment, you can hear if you start moving fast enough forward, the lift system will saturate. They can no longer overcome the downward force from the aerodynamic surfaces, and you'll just get driven straight into the ground at full power. So that's something that happens in real life. It happens in real flight, and it needed to be fixed in order for this to be something that I could fly around confidently. So how can we fix that? Turns out the loader controller doesn't really care about the pitch angle of your vehicle. It cares about the angle of your thrust, and is only using the body tilt because that's the method that it has available to influence where that thrust angle is headed. So the F-35, we have all of the tools we need to know the thrust vector angle at all times, because the 3BSM is what's manipulating that. So I used a bit of vector math to come up with the relation between the 3BSM tilt angle and the total thrust vector angle, because also we of course know the distribution between the thrust component from the main fan and the lift fan. And like I said earlier, I'm pretty much ignoring the contribution from the roll fans to the total thrust. They're not really important for this method. And then I locked the pitch level, at least in Q loiter mode, and then allow the output of the loiter controller to, instead of demand a pitch angle, demand a 3BSM deflection that produces the same amount of thrust vector angle. So now you get this. Makes it much easier to fly around. It's not putting extra stress on the lift system. It also works backwards, and it just looks a lot more natural, really, for any quad plane, not just the F-35. The backwards tilt is especially cool. The nozzle can go to 105 degrees, like I mentioned earlier, so we get 15 degrees of backwards deflection, which is enough really to get moving quite quickly in reverse. Okay, so this doesn't solve quite everything. It creates a couple of new issues. One of them, that 15 degrees of backwards tilt is, while it's enough for moving around like that in the hover, it's not really enough for braking during transition. And it's equivalent to setting a Q angle max of less than 8 degrees. Because since there's only one global setting for Q angle max, you can't specify, hey, you can only go 8 degrees backwards, but you can have 30 degrees forwards. This is limiting for the performance of the vehicle in general in hover. So if you ever get compelled to take a quad and set Q angle max to that, you'll know what I mean. Very lethargic. And the other issue here is that when you're transitioning back into hover and you've chosen to lock the pitch level, it immediately unloads the wing. This doesn't really have an airfoil. It's just an approximation. It doesn't make much lift at all at 0 angle of attack. So that'll saturate the lift system really quickly. ArduPilot does a great job of taking that load and recovering, but it'll lose altitude in the process. So that was about 10 or 20 meters of altitude loss during the course of the transition, just because the amount of lift being generated by the wings that got dumped couldn't get picked up that quickly by the ducted fans. And the deceleration is pretty lethargic as well. Even though it's a draggy airframe, it's not making a lot of drag when it's flat. So that's quite a lot of space needed to slow to a hover. So the solution to that is to allow some body tilt again, but only in the positive direction and only when we've exceeded the amount of thrust vector angle demand that the nozzle can produce. So there's two steps to the like a reverse velocity demand now. First, the nozzle will move to the negative 15-degree position. And if you're still demanding more, either in a transition or manually, it'll start to allow upward pitch of the nose. And there's just a little bit more vector math to do that. It gets a little bit more complicated, but we still have all the components of information that we need to determine this and establish the right relationship between the loiter controller and the 3DSM. We just now have two components that are contributing to the angle of our thrust vector instead of just the one. So here's a clip of the results. The lift from the wing is now maintained a lot further into the transition, and it bleeds off more naturally with airspeed instead of just immediately with pitch. There's more drag as well. And now that Q angle max really can be set to any arbitrary number because we're no longer limited in the reverse direction. We can just allow some pitch up. We were never limited in the forward direction because the nozzle can go all the way to level. And then we weren't limited in roll either. So I chose a setting for Q angle max that resulted in the small positive pitch angle that the aircraft will allow when it's got a maximum demand being a reasonable angle of attack for the transition into landing. You get a really nice, much better braking, much shorter transition in that case. So very brisk stop, looks a lot more natural, doesn't lose any altitude. Certainly helps. All right, so now I'll go into some next steps, what I have as far as hopes for the future of this project. From a software perspective, I'd really like to get that multi-turn servo functionality away from the custom software and the custom hardware. So I'd like to investigate some of those potential, not necessarily workarounds, but improvements to DroneCan or the servo firmware to allow that. I'd like to replace the frame class with Lua scripts as well, and then perhaps also those customizations to how the loiter controller works. Stand by here. Mostly because it's a little bit cumbersome for me as not a software developer to maintain that custom ArduPilot branch. Usually when it gets behind even stable releases, and then when I go to rebase it, it causes me more headaches than it would perhaps cause many of you. And then, yes, also the thrust vector based longitudinal control. That I hope to convince you guys that it's useful as for quad planes overall, not just for this project. And then maybe that can work its way into being a proper feature of ArduPilot. Some more specific things to this particular airframe. You may notice that the full-scale model or the full-scale aircraft will droop the control surfaces and hover. It'd be really cool from a realism perspective to emulate that. And that's probably something I can do with scripting right now. And then to expand upon that, a short takeoff type of flight mode, or at least modification to parameters in an existing mode that would allow rolling takeoffs with some nozzle deflection. That would just dial up the realism quite a bit, and I think it would be really cool. On the hardware side, I'm moving towards my final vision for the airframe, which is a larger model, fully contoured, nice scale appearance, and built entirely with 3D printing. So that'll be, it's a 110 millimeter ducted fan instead of the 70 that's in here and the 90 that's in my other model that was in the video clips. And the size difference between this and the larger of the two existing models is about the same as the difference between the larger model in this. So it's about 40% larger than the one that you're seeing here. It'll be quite big. And you can see that I've got the outer mold line just about finished, and I'm moving on to structural design for all of the internals that are needed for a 3D printed airframe to be strong and lightweight. And I've got the upscaled 3BSM done as well. So that's about it. That's where the project is now and where it's headed. And if you guys have any questions, fire away. Rich?
So on the integrated the longitudinal, definitely look for the tilt vectored footlights, the ones that have like the two front tilting rotors that are very very clear about it. And so yes, very much like to integrate that. We'll have to discuss more about the SLTs, the separate lift truss. Obviously, they can only provide forward thrust unless they've got a reversible motor. And so that's a little more limited.
Right.
But I think at least for the tilt vector ones, I think it's yeah.
Yeah, absolutely.
Operate.
Bill and I are working on a generalization of the multi-rotor code that will directly support a lot of these things that you are dealing with or had to hack around. So hopefully there will take some time for that to mature and get in, but yeah, this has been the types of issues you've been dealing with have been plaguing the quad plane community in particular, but also some of the more creative VTOL vertical takeoff aircraft as well. So yeah, so hopefully another year or so you'll have a bunch more tools that make this a hell of a lot easier.
Great. Looking forward to that for sure. There, Matt.
Solving the thrust vector, I assume what are you asking for the real thrust vector, and then how are you resolving how that's in terms of like the apparatus?
Okay, so the question is, how is the thrust vector output being resolved internally? The actual thrust vector angle from the 3BSM is pretty much linearly scaled around the PWM output to the tilt servo. My software that's on the custom hardware that's on the 3BSM controller runs that abstraction and makes sure it's linear. And then aside from that, the output of the loiter controller already is a thrust vector demand. So there's just a little bit of trigonometry involved in taking that thrust vector demand and translating it into a tilt servo output PWM value that corresponds to the thrust vector angle that I need. Robert?
Now, earlier on, you said that you eventually want to take those roll thrusters and internalize them. Do you have any idea how to do that yet?
Yeah, so the question is, how will I get away with hiding the roll control motors? So right now they are, it's a very thin wing, and they're the smallest propellers that I can get with enough authority to achieve roll control. The larger model that I mentioned is part of the solution to that. I really need to go up in scale in order to have any feasible way to hide those. But what the solution I think will be is a small ducted fan instead of a ducted propeller buried in the fuselage with exhaust ducting out to the underside of the wing. And I think at the larger size, I can get away with that and not have too many losses eating away at the roll authority.
Not the subject of thrust losses. So when you go from horizontal to the vertical, was that like a 15%, 20% reduction in thrust with the ducted fan, or was it end up being?
That's a good question. So it's how many losses in terms of thrust does the tilting of the 3BSM involve? And it's less than I expected. It's between 5 and 10%. And I was able to find that just by looking at motor output balance between the lift fan and the main fan, because I know where the CG is, of course, relative to the two, and they're the same power system. And there's some weird flow interactions that happen with the 3BSM. Actually, vertical 90-degree vertical deflection of the nozzle results in a thrust vector that's a little bit backwards, a few degrees backwards. So there's some flow bouncing around and redirecting inside the nozzle that's not quite straightening out all the way. So there's a handful of weird quirks like that I've encountered.
The anticipated lower bandwidth from the nozzle and the port is pass direction. Did you have to lower, I'm assuming you have to lower the Q where it needs quite a bit. Except the port performance in there.
That's a good question. So it was the question is how to using the nozzle control instead of body tilt affect the tuning of the loiter controller. And it is a very slow actuator. It's a nonlinear actuator. So the speeds that you can get for thrust vector angle change vary based on where the nozzle is at that moment in time. So it's definitely weird, but I haven't yet changed the loiter gains at all. It's flyable, it's reasonably responsive. I'm sure there's a lot of room for improvement. But so far, since the loiter controller is it's still getting what it's asking for in terms of thrust vector angle, it's just coming from a slower actuator. It probably just behaves like a vehicle with a lot of inertia would behave. So reasonable, not ideal, but flies. All right, looks like that's it.
So big round of applause for Eric. Fantastic, Eric. So, got a few minutes before the next talks start. Got Peter Barker on his tools.
Oh, not bad. I'm not
And
a citizen.
so we've got a few minutes, essentially, grab a coffee, and I try to give you drinks over there. Leave room for lunch. And we'll just have a break for a few minutes, grab a coffee, etc. Then Peter will be up after that. And I believe the F-35 is going to be up the back when it closes along, but no touching.
I don't want that one displayed.
If the cable goes bad, the most likely one is the one next to the wall. It's a very dodgy
How
cable.
do I, any ideas how I'm going to be able to switch that display between, I was hoping just to be able to switch backwards and forwards, but it's not working out that
You have to
way.
go out of a slideshow view and then switch. So when you're
That
in
is out of
slideshow,
That is out of slideshow.
yeah, and then you can't switch.
No, I can't go left and right. The
Oh, why not?
desktops.
That's up to your display.
That's going to suck.
Can you iconize and then
Let's try seeing the primary display.
that's the external one? I use it mirrored.
Yeah.
That way they're both the same. So what you're seeing is the same as what they're seeing.
Mirrored is what I want, yes. So screen display mirrored.
Yeah.
What I did didn't seem to have any impact. Like I was pushing it or not pushing it.
Right.
Didn't seem to have any impact on whether it kept working or
In the
not.
first talk, it seemed to be the one against the wall that.
Hey, perfect.
Yeah. And then we just saw a couple failures there again either. I think we need new cable.
I think a new HDMI. I might ask them whether there's another HDMI.
So Randy, you notified.
Can you go mute that? Yep, done. Great. Welcome to the third talk for the morning. And we have Peter Barker, tools, a few of my favorite things. Over to you, Peter.
Thanks. Good morning. My name's Peter. I'm IT Pilot's tools maintainer, co-maintainer with Care, Ken's here. Today I'm going to be talking about tools. Being the tools maintainer has advantages. It means you can kind of slide things in when they're convenient to you. So,
Peter, sorry, are you going to share your screen?
yes. Sorry about that. Something seems to have gone awry.
Yeah,
Yeah. I'm getting a link from Skype.
Oh, Peter.
Could have worked out better. Is that meeting still
You're
running?
already running, you're in the meeting, already. So it's in the background, just got to work out your window manager to get quick zoom to the front. So you've got to find the Zoom meeting running.
Yeah.
Definitely there somewhere. Peter uses an interesting window manager. No, you're already in a meeting.
Is he in it? He doesn't have.
Yeah, he's in there as a co-host.
Hang on, there it is. Right there.
There it is, and share.
All right.
Are you going to tell us about your window manager?
No, I don't use it for presentations very much. Is that
Yeah, well, you.
okay? And that's switching appropriately?
Yeah.
All right.
Much better. Okay,
Yeah,
over to
I'm
you,
not
Peter.
all that good at tools, mind you. I have emphasized the word "my" here because these tools suit my particular workflow. You've got to be careful of people pushing their tools onto you. They don't necessarily fit your own workflows. So I'm hoping that you'll take at least one tool out of here that might be useful in your kind of day-to-day development, but they're certainly not all going to be applicable to you. So some of the tools here are particular to Emacs. I use Emacs as my editor. There's not that many RGPilot developers that use Emacs, so we'll see. As preparation for this talk, I actually did what I've been meaning to do for many years. So many times I tell people, I've got a script for that, or why don't you use? Oh no, wait, we haven't got that at the moment. So as part of preparation for this talk, I actually made the leap and created a repository and moved my tools in and symlinked from my bin directory into this tools directory. So hopefully it'll be kept relatively up to date. But if you want to play along at home, you've now got a URL. So Python 2 has been deprecated for well over a decade now, I believe. But we have made quite an effort in RGPilot and related tools to continue with Python 2 support. That has now just changed. In the last few weeks, we've decided that you can no longer rely on Python 2 support in our tooling. We already have several scripts in the RGPilot tree which are only Python 3, so you may have already met some of the breakage. But while I was working between the two, because of course our auto test suite sim vehicle had to continue to work with Python 2, I created myself a simple script, GoPy, and you run GoPy and give it a number, and a few seconds later you have PyMavLink and mavproxy installed, and your base Python version when you invoke it from the command line, all set up for this specific Python version. You can actually see that the PyMavLink install isn't entirely clean. under Python 2. But it still all holds together remarkably. So now my system is running Python 2, but we really don't want to do that. So we'll go back to 3. So this was a few minutes work, but it really is only a collection of 3 or 4 commands, but it makes all the difference when you need to go backwards and forwards and make sure things still work. So incidentally, I will be doing a lot of this jumping backwards and forwards, demonstrating the tools. So this next one's relatively recent, my Go GCC, which allows me to switch between different versions of GCC very quickly. So I can go GCC 4 and it's created a symlink in my GCC bin directory, which happens to be in my path, to this specific version of GCC. We, of course, mainly use the GNOME Plus compiler out of that directory. But you can see that there were other options in there, 4.7, 4.8, 4.9, and I can, I hope, say 4.8. And you can see now that the symlink it's created here is now for 4.8. So you can also say release to use the RGPilot release compiler. That's actually based off symlinks, so you can actually create favorites that you might want to use for releases or for specific versions of RGPilot or whatnot. So go GCC. Reset USB. Now, this one I'm not so keen I want to run, but we'll give it a go. So when you're working with hardware is finicky. It's nowhere near as reliable as CITL in theory. So sometimes Linux's USB system just packs it in, goes out to lunch. So I have a simple reset USB script, which must be run under sudo. I'm going to type my password in the clear to everybody, right? And it iterates through all of the USB controllers in RGPilot and just turns them off and turns them back on again. But turning things off and on again in an automated fashion is cool. So that's reset USB. So how you usually know this has happened is that you go to Flash and autopilot and suddenly your music stops. My music it goes out via USB. So my music stops, I know that I have to run this script, which of course means leading over to my laptop and using its keyboard and mouse to actually run reset USB because my normal keyboard and mouse are no longer working. ARM-NM and ARM-OBJump well, ARM90 ABI none script, but just with a few convenient options. So my favorite options to actually see what symbols are inside a binary. Now, honestly, I didn't actually look at what these options do when I did this, and that grep looks very strange, but the tools went in as I used them. So it looks like we're filtering to specific symbols here. So, and of course the OBJump equivalent. So when you actually want to look at things a little bit more closely, then those options are fairly typical when you invoke OBJump, of the ones you usually want to throw in to make things readable. Assuming you understand assembly, I guess.
Read that up the back. We need a bigger font. All good. All good.
Can you explain why do you need to look at which symbols are in a binary? What do you use that script for?
Yeah, we can get to that on a later slide, but most recently I've been using it for in relation to the custom build server. So when you want to add an option to the custom build server, you need to add something to the build options.py, which is in our tools directory. To know it has a companion script, which is extract features.py, and it is the script which can look at the binary and tell you which features are in that binary. And that tool needs a symbol to latch on into that binary and say, if this symbol is present in that binary, then you have that feature. Now, we'll talk about that a little bit more later.
also helps, like, if you've written a new piece of code, it sort of, you want to know how much frequency it has, you can sort of say, okay, this function for this particular class gets this much flash or RAM or whatever as well, so this and that with.
So in terms of branch wrangling, I have a lot of branches. I think I've got over 100 open PRs at the moment, at least in RGPilot. I've got several hundred more WIP branches. So I need to wrangle branches fairly efficiently. And these are some of my favorite tools to do with branch wrangling. So if I have a branch which I want to do some work on, which might be a little bit, how about rover guided, no GPS? If I check that branch out, I'm going to do some work on it. What I might want to do, I haven't touched this in quite some time. There's a good chance I'm going to stuff something up. But if I can make a trivial backup with a simple date branch. And because branches in Git are ridiculously cheap, this operation takes absolutely no time at all to run, as you can see. And you can see that the branch name is namespaced into the backup. It's kind of, well, I'm calling it a namespace. It's just a name, but you've got a backup namespace, and it really is just backup / old branch name followed by a date string. And if you have a look at through my branches, you can see that there are a vast number of backup branches here. So they're really cheap, they're out of your way, you don't have to worry about them once you've made them. But I tell you what, you don't need to reuse very many of them to make it worthwhile doing this. The next one is somewhat more time consuming. It's date tarball. And this is another way of making a backup. I wrote this after one too many oopses with Git when I was first learning it. And date tarball, people are probably already guessing what it does. You give it a directory name, and after a while, you have a tar file, which is just a dated file that has the entire contents of that directory in it. Now, that one could take a while. Then again. Okay, so now I have a dated tarball of my RGPilot directory. Now, if I do whatever I do completely stupid in that RGPilot directory, and I'll be showing a tool later which you can be completely stupid with, and if you completely destroy that, you completely destroy the .git directory, now you've got a complete backup, and it does not take very long to make, as you saw. So I often recommend to people that if they're going to get ambitious with Git for the first time, under Windows, make a zip, a dated zip. They don't take long to make. So tar, as you can see, is very fast. So now, GCO, I tend to, I do test a lot of PRs, other people's PRs, and a lot of new contributors I don't have remotes for. So I wrote a tool that makes it very easy for me to test other people's PRs, particularly new contributors. So that's GCO. And to use this, I need to find a PR somewhere here. Yeah, okay, here. So I'll go to, probably won't be a new contributor, but we'll find oh, this one looks interesting. I don't think I've seen this contributed before. This UI element here, if you click on this UI element here, you can see that's the kind of the copy mystery meat icon. So now I've been told it's copied. So if I go back to my shell and into the RGPilot directory again, I can GCO, really, and paste. And you can see that's not worked. Let's try a different PR. That's actually, yeah, demos. I might have actually broken this, moving it into the, yeah, I have broken the script, moving it into thing. What it should do. So this is my one flaw for the entire demo, the entire speech, by the way. So what it would do is adds the remote, fetches the remote, and then checks the specified branch out in a detached head state. And the detached head state, you can then, for example, update your submodules and then run whatever tests you want to run in that detached head state. Sometimes you want to rework that PR a little bit, maybe fix up the commits a little bit, and you can do that all from the detached head state. So you can fix their commit message, And then I have another tool, toggle remote type, which allows me to turn that HTTPS URL back into an SSH URL. And then I can force push over their branch. And this takes very, very little of my time to actually do. So just trying to make these workflows a little bit more efficient. Then we've got rebase PRs and rebase whips. So as I said, I've got a lot of PRs. If I git checkout master and git pull, then I'm pretty sure I merged a PR a few minutes ago. So now I've got new commits on my master branch, but I've got vast numbers of branches that I want to keep up to date with master on the basis that if I fix the conflicts early, then there's less code around that is going to conflict with, so the resolution should be faster. So if I rebase all of them at once and just solve the conflicts as they come up, then there's less time keeping everything up to date. So this is going through all of my PR branches and trying to rebase them. That one was merged, so it's actually just pushed the branch, just deleted the branch off GitHub, because the branch was fully merged into master, so no longer need that PR branch. It's deleted it locally and deleted it on GitHub as well. So it's going through a few. I'm hoping for a conflict so I can actually, show what happens then. It's not, a lot of these are terribly hackish. So, if this one does bomb out with a merge conflict, then I'll have to do the entire rebase from start. It has to do all of this all again. But, often you can do this while you're off doing something else. Unfortunately, no conflicts on all of those PRs at rebased. And the reason I don't have conflicts, I guess, is I early rebase often. All right, so I also have rebase whips. So all of my whip branches. So that's a little bit on my branch wrangling. Come on, conflict, no, all right. So efficient code editing. I have done a bit of work here and there in the auto test suite. One of the changes I made a couple of years back was to change it so you can set multiple parameters at once. So we used to have set this parameter to this value, set this parameter name to this parameter value, set this, but then you'd have to, on another line, say set this parameter to this other parameter value. Well, we made a set parameters call. So it takes a dictionary of values to set. Very useful because it's fewer round trips to the autopilot, because it basically just starts saying, give me this value. And if it's not what it's expecting, it says set this value, and it does these in parallel. So you can do things with the simulated autopilot faster, and it actually does make a fairly significant difference to time required. So the refactoring to go from one to the other was just annoying. So I wrote a short filter which fixes the old form to the new form. So I just ran that on that little code block there. So you can see that this was 2 set parameter calls, and with just an application of a little filter written in Perl, it did all that automatically for me. There are much fancier tools to do this, by the way, semantic analysis tools and stuff, and I have played with those many years ago, but this is just a very simple Perl script which takes text in and spits text out. Emacs happens to make it very easy to apply those filters to code blocks in a buffer, but a little bit of research showed that you can apply the same sort of thing with an extension in Visual Studio, for example. So the simple Perl. So yeah, this is the code down the bottom here. I actually added the comments before I committed into that new repo I mentioned. So then there's Slaughter, which I wrote many, many years ago, and it's named that way quite on purpose, because if you stuff it up, it will like turn all of your files letter for letter into letter X, for example. But you can give it a directory in which to start and a regular expression and a substitution string, and it applies that to every file in that subtree. I think you can filter based off file extension. Again, it's not the only tool out there that does that. There are other Perl-based tools actually that do that, but you know, this is the one I wrote. This is the one I'm familiar with. So other people might find that. No, I'm not going to run that tool just in a demo. No, it doesn't actually. There's a few safety guards in there that try to stop you doing silly things, and there's always that bake tarball command I mentioned earlier. So code validation saves you time in the long run. So it takes time to write things like these pre-commit hooks, but it does mean that before you commit your code locally, if you use these pre-commit hooks, you know that they're going to pass the CI test because it's the same tests being run in CI as you can then run locally. So I run the pre-commit hook. So if I introduce a syntax error into here somewhere let's find a for loop and break it maybe. Oh, well, we can just introduce a syntax error here, hopefully. Yeah. Add the patch. Hopefully. You see that that commit failed locally for me because I've got this pre-commit hook in place. This pre-commit hook is just a symlink, by the way, from .git/hooks back into the IGPilot tree itself. So they're kind of, you can optionally run them. We do supply them, but as you can see, it stopped me from committing a syntax error. If I'd pushed that up, I would have got CI would have stopped it being merged to master, but this can really shorten those loop times. So. Now, size check is actually a wrapper around size compare branches, but size check is a really simple thing which allows me to, when I create pull requests, show that at least on a subset of our boards, board vehicle combinations, that the changes are either non-existent, zero size change, or at least small enough that it's probable that we haven't lost a feature in IGPilot. So if you're only trying to do a minor refactor and suddenly you find yourself saving 5 kilobytes, then that's a fair indication that you've done something wrong here. So the output here is output from size check, and size check really is, you just invoke it on the command line as size-check, and eventually it spits out this block with board in the left-hand column, then target across the top here, and then the size change down in here. So in this particular case, I can actually just show you the files changed here. You can see that it's just the mount library changed. You can see that over here. So, you know, the changes should be restricted to that back end. So then you can ask yourself, do these things make sense? Star means that the output binary is byte for byte identical to what was built on what was built on the master merge brand, the merge base with master. So star means identical. 0 means exactly the same binary size, but there's obviously some change inside. Now, a lot of those are benign. So for example, in IGPilot, we were using __line __. So any vertical white space above an __ line will change the binary output. And we still actually use __ line _ in some places. We have a new define __ AP _ line _ which you can use instead. And when compiling in this regime to check your binary differences, it sets AP line to a fixed value and a few other tweaks here and there to show that the binary output really is identical, even if it doesn't look like it. Negative numbers are good. So this one saves 64 bytes on Durandal Copter. And of course, on a board like Sky Viper, which doesn't actually have a mount, you'd expect 0 size changes, and we can see that in here. So then we've got size compare branches, which size check is based on. And it's a reasonably versatile tool. Ordinarily, you run it to, you've got a branch which is based on master or based on some other branch. You can specify the merge, the branch you want the merge base for. It takes you can specify which vehicles you want to build for, which boards you want to build for. But the way I run it is I have a spare machine at home and I run it with -- all boards and all vehicles. And it does this grid that we were looking at, but for every combination. And that takes about 7 hours on my, reasonably elderly now AMD 5600X. That machine's a few years old now. 7 hours to build all the binaries on master and all the binaries on this branch and compare them. Now, if that's your primary work machine, probably not an option, but even overnight, it means that you can have, once you've built them all, you can be sure that they all build on your branch, and you can eyeball it and make sure that everything's changed as you expect. Something else you can do is if you're adding a feature to ArduPilot, which has a define associated with it, or something you put into a HWDF, more to the point. You can specify that on the branch that I'm trying to validate, apply this extra HWDF file. So you can turn that feature off and make sure your branch compiles with it off, or you can turn it on if it's off by default. And you can specify a different HWDF file for master, or you can specify a combined one. So really good code validation tool. If I'm doing a refactor of some description or another, I'll usually run this on that spare machine. So the other major, where I've been splitting these features out a lot lately. So, and when you split a feature out so that it can be conditionally compiled into ArduPilot, we're really liking people to add it to the buildoptions.py script so that it appears in the custom build server, which I won't be demonstrating today because it's been done. The buildoptions.py, I can show you what that looks like. It's not actually all that hard to understand. This is the test buildoptions.py. The build options is actually in tools scripts. So if you're adding a new, when I say a new feature, I'm thinking like if you're adding to the C++ code, a new generator or a new sensor which can be compiled out or something like that, then adding a feature to the buildoptions.py is a really easy way to allow people that are in resource constrained environments, so, I don't know, Pixel 1 meg, still give them the option of building your feature into their board, so long as they're willing to sacrifice something else, or often many other things. And this isn't actually all that hard to find space, because those older boards still have vast numbers of rangefinder drivers or optical flow or beacon support, or it's surprising what we actually still throw into those 1 meg boards that you can just get rid of. So the other day, somebody wanted to run Q Auto Tune on their Pixhawk 1 meg. And that's the one plain mode I think we don't compile in on Pixhawk 1 meg. But using the custom build server, he could just go in, uncheck a few things, turn on Q Auto Tune, and now why you'd do that, I'm not sure why you'd want to, but you can still run Q Auto Tune on that device. Reusing old hardware is good, I guess. This test build options is written to test that build options script. So the build options has a dependencies column, and that often isn't correct the first time you try to do things, because you try to compile it with the option enable or disable and discover that your dependencies aren't correct. So test build options tests compilation with and without the feature built in, but tests turning test the defaults, tests turning everything off, tests turning everything on, and then tries turning each feature off individually, and then tries turning everything off except that feature to make sure that we pull in dependencies correctly. So it's reasonably thorough, and I think the time taken kind of reflects that. So.
So on the code validation of those scripts that you would, I guess, appreciate anyone who makes a pull request, we would suggest they kind of go about that to this. How about adding those to our pull request template? Your big one says here's some links, make sure you try these.
We could. The question is, should we modify our GitHub pull request template, basically the default document you get when you start up doing a pull request on GitHub, modify that to perhaps at least suggest to the people that they could do this. I don't know we want to raise the barrier to entry too much for new users who, they're struggling to get their git commit messages correct, or pull request to the right branch, that sort of thing. We could suggest that they do it, but I think the vast majority of people maybe just cut it out of the template anyway.
Well, I think it would be the opposite effect, because now we'll make a request, just walk away, and if something's wrong, this tells you there's going to be something. You can check yourself. There will be something.
Yeah, just for the people listening at home, Tom suggests that perhaps this would make people a little bit more conscientious when making pull requests, to show that they've made at least a token effort to test their code. Because we do get pull requests to our department, which obviously have not been tested. They just don't compile. The person has had a good shot at it, but without testing, I think that's one of the things that these tools do, of course, is by putting that in the PR. When I take this to dev call, it reminds me, for starters, what testing I've done on it. But it also shows, that it has gone through this minimum level of testing, and here's the evidence to show it. Of course, this block replaces what we often do on dev calls, which is we go back to the CI and click through the build sizes thing. One of our CI steps shows the difference in build sizes. That takes time on dev call. You've got 24 people all sitting there and watching, as we go and look through those build sizes. If we can just have it in a comment straight up here, it can save time in dev call, and that's quite useful, I think. But yeah, Tom, if you wanted to do a pull request against the template, we can discuss it at dev call. Gather SD data is, log management and analysis. So I do flying on a variety of different vehicles. Sorry, go on.
If suppose I don't want to use certain feature, so can I define that under test build options, and whether that son of source code will also be compiled when making the build?
Yeah, build options.py is only used for our custom build server. There's actually a second use we have for it, but yeah, just for the custom build server. If you're trying to make yourself a what we'd often refer to it as an OEM setup, that's where you've got vehicles that you're trying to push out the door, and you want the same thing on each vehicle, and you want the same defaults.parm, and you want the same options built in or not built in, that sort of thing. We'd usually suggest that people go, and you're building the code yourself, then would usually suggest people go through the OEM setup page on our wiki, which walks you through the steps of setting it up so that when you configure the RG pilot for build, you actually specify your company name dash board name or vehicle name or whatever. And when you do that, you get all of the options you want in there, none of the ones you don't, and your defaults.parm. Your scripts can also be incorporated this way. If you're a vendor pushing vehicles out, we really do recommend people look at doing things that way. Yep.
Okay, so can we use this test build options there? Suppose I don't want to use certain feature, but it is still residing in my source code.
Yeah, sure. If you add the option to build options.py, and then run test build options, yeah, that's definitely going to work. If your new feature, sure. Okay, so yeah, I fly a lot of vehicles, a lot of SD cards. Gather SD data is a script that I run when I'm extracting logs. The basic workflow is I eject the SD card out of the vehicle and attach it to my laptop via, unfortunately, an external USB dongle on this one, which is sad. It's just got a list of known SD cards, a static list in the file. Often I give these SD cards VFAT labels so that they're recognizable for that vehicle. Gather SD data knows about these mount points that are going to appear under Linux, knows where the logs are on those, and moves those logs from that SD card to be next to the equivalent T-log in my normal file system on my laptop, so that they're correlated against the flight, the parameters, all the stuff that MavProxy dumps into the directory when you're flying your vehicle using MavProxy. Now you've got the bin files right next to it, which I find very, very convenient. The other thing it does actually is runs the DroneKit log analyzer against all of those files as after it's moved it onto the normal file system. It runs DroneKit LA against those files and spits the results out to a text file, so I can review that to see if it's actually pulled up anything interesting. The other thing, of course, I do is I've got summary tools, which I haven't included in the presentation today, which go through and make summaries of based off all of those DroneKit log analyzer outputs. So these next tools are in the RGPilot script directory. powerchange.py, du32change.py, solution status change.py, and I've got a pending PR for sensor status change.py. So RGPilot in its log messages has some bit masks which indicate the state of the vehicle, and understanding how these have changed over time used to be quite problematic. A fairly recent feature, I think, that Mission Planner has gotten allows you to plot individual bits out of data flash log messages, which kind of makes these tools a little bit redundant, I think. But if you point these things at a data flash log or telemetry log, depending on which one is applicable, then it will tell you how these things have changed over time. So if we look at solution status change.py, if we point that, it's got the bit descriptions in here, and it's obviously looking for a data flash log. So if I point it at a data flash log, oops, then it's now looking through the log file and is telling you how the EKF solution status bits changed over time. And this is very useful, actually, if you're looking at a graph from MavExplorer. You've got timestamps where you can correlate the timestamps with these messages, and you can say, okay, yeah, GPS was glitching at that point, so let's have a look at our vibes, that sort of thing. And yeah, the other scripts here kind of much the same. So powerchange.py tells you how the power inputs to the autopilot have changed over time. So Many modern autopilots can source their power from different places. So pairs of power bricks and USB and servo rails, I guess, and whatever else. And if they're reflected in the power message, then this will tell you how they've changed over time. So somebody was relying on USB and they suddenly lost USB supply. This should tell you. And DU32 change.py is a RGCopter specific tool which tells you how RGCopter's DU32 message changed over time. DU32 is supposed to be a generic message that just is an unsigned 32-bit data flash log message. Copter is the only vehicle, perhaps sub as well, my apologies, that actually emits one of these by default. But it actually has some really, really critical information when you're doing log analysis. So in particular, your landed state, I think, is one of the critical ones in there. So this one tells you how that's changing over time. Traditionally, it's been quite a bit of work to prise that one apart to work out what's been going wrong. So there is a question as to where these belong. Currently, they're right next to RGPilot, but they're heavily influenced by the PyMavLink tools. They are RGPilot specific, so we may get more of these over time. We'll see. Oh well, that's a sudden and abrupt end. I was going to show the custom build server, but we may as well go straight to questions. So I don't get it like a room full of silence. I've got some prompts up here. Hopefully you can get something.
So so it's mostly Python and some Perl.
Yeah, very little Perl nowadays. Most people can't stomach Perl, but for regular expression work, for dealing with text, I really do quite still like it.
Yes.
I haven't kept up with most of the recent developments in Perl. All my Perl's still Perl 5. So before I went completely insane. Nowadays, I can reach for Python as well. And if I'm contributing something back into the RGPilot code base, it's going to be Python because Perl's a dead language.
Yeah. The GoPy, I've got a equivalent PyVer. It just symlinks use it in Python to Python 2 or Python 3 and assumes you've already got it installed. Very much faster. Is there a reason why you reinstall the PyMavLink and that proxy each time?
Just because I found that I was doing that at the same time. And of course, mine does much the same thing. It removes a symlink in my squiggle/bin directory, I think, and symlinks Python 2 or Python 3 into that location. Just usually when I'm testing Python-y stuff, it's often PyMavLink or MavProxy, so it kind of makes sense. Where things do get a bit slower for silly reasons is that if you're only changing MavProxy, then MavProxy is relatively quick to install, whereas PyMavLink isn't necessarily. So,
I do swap my Python versions and all that.
Yeah.
It needs to work fine. I think it just continues to use your already installed proxy that it was, and just changes the link to a different Python version.
Yeah.
It comes with the package, which can just say update alternative and give you the list of installed Python version and can just see which Python form.
Yeah.
It'll just work magically. So it's one way to work. Yeah.
Sorry, question at the front here.
Any tools for fast block download? Basically, whatever block we download takes a bit much of time.
So the question is there a tool for fast log download from the autopilot to the companion computer, to the laptop? Where were you thinking of?
Connecting the USB and transferring the data. That's it. So
Yeah. So we actually hit the limits with the log transfer protocol when you do mission planner log transfer that way. We actually come fairly close to the limits of what we think is possible with the current way that we do the USB stuff in RGPilot, my understanding. Yeah. And FTP is actually slightly slower, surprisingly, than the normal log transfer protocol. So I've been told. what we sometimes recommend to people is that if their logs are large, if they're running big vehicles with companion computers, avoid the problem altogether and stream those logs to your companion computer and transferring them from the companion computer via Wi-Fi, or some partners are starting to transfer them directly into the cloud while they're flying. Would probably suggest that at the moment. My understanding though is that USB transfers might be getting faster on more recent hardware. That's
But that's still like, yeah, it's not going to be really good for like a gigawatt. So
Right.
He said, according to the best solution,
and just for the record, that was Cube Pilot and Krause popping in with their a segue into their Ethernet talk, which is next. There was a question.
Online.
Mhm.
I believe that by using simulation on hardware, not just, I can also test processing time. Do you plan to use simulation on hardware in the future?
Simulated SITL on hardware is useful for a great many things, but not so much performance analysis. And the reason that is that the simulation is running on the same CPU cycles as the ArduPilot firmware itself. Now, with multiple cores making their way into ArduPilot at some stage, it might be that we might be able to use it for that purpose. But at this point, I don't think that's actually a goer. Now, that actually, though, I think does feed in with something Tridge mentioned earlier with performance analysis, a sampling performance analysis thing. So it might be possible in future to do that.
You can do micro timing analysis on hardware by doing
That's true.
Turn off interrupts, turn on interrupts, and blocking between, you get very accurate timing.
That's true.
And that works well in simulation. So great, for example, you want to know if this particular function, how many microseconds this function takes. That is very accurate on sim on hardware.
Yeah, I'll just repeat that for the record in case it didn't get. Tridge points out that if you can block your code off so that interrupts aren't a thing, you can do the sorts of performance analysis we've traditionally done on embedded hardware, which is drop in your microsecond timers around the code you want to test and just read them out afterwards. Sim on hardware in this case really just gives you a convenient way of actually activating that code.
Peter, can you talk a little bit about the requirements or assumptions that you're making with the tool to check CI before pushing? What environment assumptions you made there?
You're referring to the pre-commit hook. I believe that's limited to do you have Flake 8 installed and do you have Python installed? I think so long as you can run Flake 8 against a file, then that will pass. The way that tool works, by the way, is that not all of our Python files in the ArduPilot source tree are actually compliant with Flake 8, but quite a few of them nowadays have a marker at the top of them saying, yes, this is Flake 8 clean. And then this CI process we run just makes sure that it stays that way. And, the concept being gradually over time, more things will get this and new things should have it so that things get cleaner over time.
Yeah, so for your tool with pre-commit checks, is it possible to plug in other third-party linked tools along with the ones that you've made already to do the checks before you commit the code?
Yeah, sure. The question is, can you hook in more tools into the pre-commit hook to make sure that your code meets, I guess, higher standards, your own higher standards before actually going into your own source tree? And yeah, absolutely. That's not a problem. There's a hooks directory where you can just go in and put in whatever scripts you like to test your code actually complies with your company's requirements. Bear in mind, however, that if you try to run multiple things like Flake 8, they may end up fighting. So there's a Python tool similar in some functionalities to Flake 8 called Black, I believe. which we kind of bounced a pull request from Brian from, because it looked like it was just going to fight too much with Flake 8. One of the issues with Flake 8, of course, is that, and a few other things we do now in Autopilot, is that we have raised the barrier to entry, which is to say somebody who wants to help contribute to the tooling, please do, now has to get over this additional hurdle of making their code Flake 8 compliant. And it can be, you know, finicky at times in terms of the white space it requires, but that keeps our code quality high. So trade-offs.
Also, for your gather SD data, how exactly have you done the correlation between your data flash log and your log? Is it on timestamp?
Yeah, purely off timestamp. And if you happen to have, for example, SD card logs which you've booted the vehicle and it hasn't ever seen a GPS or hasn't seen a GPS, sorry, GCS hasn't supplied it a timestamp or a GPS hasn't supplied it a timestamp, then all of your log file or those log files for that session will come in at 1980. And Gather SD data just says, no, not going to deal with this problem. It can't, it doesn't try to correlate past that point. It could, right? It could actually go in and have a look at the log files, see if it can actually identify the vehicle from the contents of the file. We do have, for example, parameters which you can use to identify the vehicle, that sort of thing. And of course, you look for yourself, it's all in that repository that I mentioned earlier. So
We have some users who only care about like a section of the log that, you know, they have a particular mission and they only care like a part of the log, and they want to automate the analysis of that log. And they ask all the time, discussion forums or partners who ask all the time that what's the way to get this done? So do you have like a base script which people can look at to build these tools?
right. So Rashad's question is, how do you section a log, a large log, so that for easier analysis? So you fly your vehicle for 5 hours and you have a 1.5 minute log file to deal with. Our tools have got a lot better over time at dealing with large logs, but they're still problematic. So the answer is there's a few different ways to approach it. There are existing tools, of course. So there's Mav extract .py, which goes through your supplied log file and extracts just the parts where you are flying automatically in auto into separate chunks. And does, I think, a small amount of analysis on them for you as well. This can be very handy if you've had vehicles sitting on the ground for an hour and then you've gone fly and suddenly you've got a big log for no particularly good reason. Second go-to thing would be probably Mav log dump with a condition. So you can say condition is timestamp between this value and this other value. Being a PyMaverick style conditional thing, you're limited only by your imagination, really. You could limit it to just between these latitudes and longitudes. You could limit it just between these waypoints, that sort of thing. And if you can get your head around writing conditionals for Mavlog dump, that's kind of a good kind of reach for tool.
It's probably worth pointing out that Nav extract and Mavlog dump
True. Yeah. James just clarifies that those two tools I've just mentioned are actually in the PyMavlink repo, not in the Autopilot repo. So tools all over the place.
So as a new Autopilot developer, I found that there's a suite of awesome tools like you presented here, and lots of pre-existing ones. Is there anything that can be done to increase the visibility of tools to make it easier for users to know that, oh, hey, there's a tool for that?
Ryan's question and Tridge's response, but which I unfortunately didn't catch.
Look, the answer is give a talk at the conference. Increase visibility.
So Ryan's question is about discoverability. And I guess there's a few different answers to that. Yes, talk. Perhaps we should be expanding our dev wiki to have a better. I did go a bit of effort to, for example, document the auto test suite, which I haven't actually talked about today because I spoke about it last time. The other thing you can do is just have a look at what's in the tools directory. Just do an ls in there and see what it does. If it's a Python script, it'll usually be a dash help. And if it needs documenting, then but I think the core answer to your question is it needs to be on the wiki, in the dev wiki, easily findable.
Thank you, Peter, very much. Okay, we've got just a few minutes before the next talk, and it is great, by the way, speakers can finish just a few minutes early, listening out and stretch their legs a little bit, and maybe grab another cup of coffee, see if there's any more of those treats over there you want to sample. Lunch is going to appear at the end of the next talk, depending on exactly how long the talk will go for. But there'll be hopefully some Romish funds come in by the end of the talk. So the next talk Audio again. Right. Okay, so everyone ready? For the third talk today, we have Tom and Sid talking about networking. So over to you, Tom.
All right, thank you, Rich. Yeah, so my name is Tom Pittenger. I'm Magic Grub on GitHub, and here is Sid. He says hi. Yeah, so we're talking about adding networking support, native networking right into the ArcherPilot stack. But first, I figured since GPT exists, we should at least try to have it write something for us. So I actually tried this. This is just a quick tangent. Write a presentation adding networking to LWIP, and then that actually was surprisingly good. But then, of course, you have to add in stereotypical slang. So we can totally do that. It's actually hilarious. We won't do it right now. I'm just kidding. So intro to LWIP, which is the lightweight IP stack. That is the IP stack that we're using on ArcherPilot. It's just designed for kind of embedded systems, low memory footprint, that kind of stuff. Talk about how we enter it into the autopilots, some MAC address stuff, and then stuff we've been doing with it. So, and of course, a demo. I got some hardware here. So the features of LWIP by itself is it's just optimized for small flash and small RAM footprint, with everything included in ArcherPilot, with all the features that we're basically going to use and all the parameters and configuration and all that. It takes about 80K of flash. So not really that much considering it's a fairly significant feature. I mean, it's a very significant feature. LWIP is the IP stack of choice that actually comes embedded with ChibIOS. I've used LWIP in other applications before my life at ArcherPilot, but it's been around for a while, and it's nice to actually came with ChibIOS. It's kind of wrapped in it or embedded in it. It implements all the usual suspects for IP protocols: ARP, IPv4, 6, UDP, TCP, amongst others. The ones I have in bold here are the ones that we've implemented that are exposed, that are actually actively being used. But the hooks are there to do all kinds of other protocols. They're just defined out for the moment. But yeah, so we have a web server. It'll handle DNS requests. SNTP is for the time protocol. So if you have internet access or some sort of local time network, you actually can, the aircraft would know what time it is without a GPS. All that sort of stuff. The general interface to ArcherPilot is going to be through the AP networking library, and it's fairly straightforward to set up. You just set your Boolean for enabled, and most of these require a reboot to take effect as well. You can set your IP address. Right now, there's IP 0, IP1, IP2, IP3, and you just set those numbers to be what your IP is. And that's if you want to do a static IP address. There's net DHCP to turn that on, and then it'll boot up with IP of 0, and then it'll just be asking the network for a DHCP server to give it an IP. And the net mask is not, you don't say 255.255 or whatever, you actually just say how many bits you want. So the example here is 24 bits, or 24, and that'd be equivalent to 255.255.255.0. MAC address is, we have some defaults in there, but it's just 6 parameters. You can put in whatever you want, essentially. But there are some mechanisms we'll talk about later that make it more unique for as people start using this. And then net options, which is a bunch of bits that you can turn on more larger features, such as TFTP, net BIOS, time servers. You can do a mail server. There's all kinds of other stuff that we can start doing on there. And a lot of these are all defined in a way that you can define them in your hardware-defined file for your build target. So you can say that this device will boot up and it'll have net BIOS of this name or something. And then there's going to be a net and then a number and type for each add-on libraries. So right now we have just 2 libraries that are kind of like embedded C code files,
typical drivers in the Archipilot library that are running within the scope of this library, that you can do whatever custom stuff you want in the C++ world, and you'll just get updated 1 kilohertz. And the two that we implemented is a speed test, and another one is a latency test. But you can just build from those examples to just build whatever send receive sort of UDP, TCP, whatever examples you want. For MAC addresses, LWIP comes with this kind of defined default one. It's sort of an invalid one. It's kind of like having your IP address on a computer where it says like 169.1 something. It's one of those like non-routable-ish, but it works. It's just expected to have lots of people around the planet have it. It's designed to be replaced with more unique numbers. So it's kind of a placeholder. On QPilot, they actually own a 24-bit block of MAC addresses. So they have A8, B028, and then the last 3 bytes on either with the QPilot hardware or not. I built a mechanism into it so that it takes the UDID of your hardware and replaces it as default. At least you can still replace it with whatever value you want, but the default becomes whatever the UDID is of your hardware. So you should be getting more random or more unique devices as there's thousands and millions of these come online. And performance. So a little bit of a disclaimer here. This is, all this is an initial, we got this working. There's lots of things in Archipilot that don't expect tens of megabytes of throughput and stuff. So there's lots of bottlenecks that exist that we know about, that we just need to spend some more time in to make sure we don't break anything else and that. So there's some of them that we know about, and I'm sure as we go along, we can just, it's one of those things we can optimize forever on this sort of thing. So right now, I think it's just kind of considered preliminary. So it's still pretty good. It's a lot better than Serial, but it's going to get better. So first, speed test. The idea is just fill a packet with 1472 bytes, and they can be user defined, or if you in the parameters of this library. So if you say like net 1 type 1 or whatever, when you do that, it'll pull up some more parameters, and there's like what kind of content you want or whatever. You can send just all zeros or all fives, or if you say -1, it'll send a string of like, welcome to Archipilot and whatever. That's just what it's spamming out the port as fast as it can. So that's what this is. It's just send a string over and over of 20 characters or whatever, saying hello world kind of thing, and to a port that you choose. And it works at like 87 megabits. Like 80, it kind of varies a little bit depending on what's going on, but it's 85, 84, it's 87, pretty fast. So this is at the C level in Archipilot. Now we're talking down to LWIP, talking down to Chibios, and that's just raw ability for us to push data out. So we're basically limited to the 10100 link on the hardware we're using. But in theory, if this was on Raspberry Pis or some x86 systems, you would get gigabit kind of speeds too. So there's nothing in the Autopilot itself that's inhibiting the data packets from going out. It's more about when we start interacting with data that is using it, like when we do like MavLink and the SD cards and all that, it's going through other mechanisms that aren't expecting ginormous amounts of data. So latency test. So I've built this in. We didn't have time to really test it thoroughly with multiple hardwares, but I have this little library that we can start testing with, where sort of a worst case latency test where you have on a local LAN with a switch, a couple hardware connect together, where you turn on the feature and they would say, they send out one 32-bit number of the number 1, and then if anyone receives that, they'll take it and then increment it and send that out. And then whoever receives that would increment it and send it out. So you have 2 guys going back and forth, and just how fast can the number grow, right? So that's the kind of a ping-pongy sort of thing of just latency of here's 1 byte. You got a whole bunch of overhead for IP routing and all that, but just with 1 int of a payload, how fast can we just slam that back and forth between the 2 guys? And so we don't have the results for that. We haven't done the test, but we're guessing it's somewhere in the 200 to 400 sort of range. But we, results are TBD for that. So also TFT, question?
We have a few questions on YouTube if you can answer them.
Sure.
And also echo them out on the mic so that others know what you're talking
Yep.
about.
Your questions.
So, can the playman asks if SSH and SFTP is supported?
SSH and what?
SFTP.
SFTP. So I was just about to get to the TFTP. Right now, we don't have SSH capabilities as far as it wasn't a default thing that came with the LWIP. It's still something that we could implement. Nothing stopping us from doing that, but it's not currently in there. As far as, and same thing with
FTP.
yes, FTP
So you
or
also will have to probably include SSL libraries and encryption as well. So that's, yeah.
yeah, anything encryption related. There is support for HTTPS, but otherwise, there's encryption right now is absent for the most part. There's hooks for it. We just haven't implemented that stuff quite yet. There is the one that does come with it is TFTP, and that's trivial FTP, which is a much more primitive, lightweight, low memory implementation of FTP. It's not secure at all. It's just designed for use within networks, within local networks and stuff like that. It doesn't handle packet fragmentations and stuff like that very well. But it's machine to machine talk that are near each other. And with that, we were able to kind of transfer files or transfer data from a computer to the SD card at, well, from the computer to the device, it would receive it at about 1.4 megabits, and then we could read from it at 2.2. So we need to find out what those limitations are. I know a lot of it is TFTP itself is a limitation. There's no windowing or anything. It sends a byte, waits for an ACK back before it sends another one and stuff like that. It's all, there's no queuing of that sort of stuff. So it's designed to be very low memory and stuff. So it would be nice to see where this goes when we put it in a more TCP oriented windowing proper FTP implementation. So this will definitely do a times 10 or so. I'm guessing. We'll see how that goes.
And the other question is, how does this interface, like, what's the port that you're going to use?
So we have a hardware. I got a hardware slide here. Think about what the hardware options are in a minute. Anything else?
No.
All right. So maybe how would you talk about this one?
Yeah, sure.
Yeah.
I mean, so we are adding serial extensions basically in RGPilot. So this has been, something that I've been working on from the DroneCan side, and I had, pictured that this is the same thing we'll do with IP as well, where you have currently in RGPilot serial 0 to 9, basically 10 serial ports, which, connect to a physical serial UART device. So we want to be able to have sort of more pseudo serial ports, sort of, like be able to select what physical type of that serial is going to be. So in this particular example is like we are going to have something from A to F for now, and maybe even more in the future, where you can basically select what type of physical type you want to send that serial over, and you will basically set the physical type, and it will just load the parameters that are relevant for particular physical type. So if it is IP, it will, what's the destination IP, what's the port, and you set that, and it will just stream your UDP package to that particular location. So that's sort of the architecture that we are going for. And, of course, this will just appear as HAL.serial in the, RGPilot space, and you'll be just able to use any sort of protocols through serial manager that you are able to, but on different physical types. So this is just ease of configuration, sort of ability that this serial extension will give users in the near future. So yeah, I mean, I'm going to talk a bit more about it in DroneCan space as well. So yeah, you can continue.
Yeah. So in short, it basically allows a virtual serial port that you can connect any protocol to IP or to CAN. So that way, over your IP link, which you can configure it as TCP client server, UDP client server kind of things. Then you can become it's just talking to it as if it's a GPS, or if it's a rangefinder, or if it's some Mavlink. Any sort of anything that's in the serial manager protocols. It's just So without having a physical serial port, you can just be talking as if that's the port over the IP. So that allows us to have, a dozen Mavlink ports or whatever, and you don't need, it has nothing to do with serial. And then do all kinds of your custom protocols. So yes, so and how this interacts with scripting. So we have scripting basically has hooks in there now for us on our branch that is just raw TCP and UDP packets. So you can do whatever you want. A server client on either of them, and it'll just wait for messages, and all the hooks that we use down in C, they're all brought up to the server side. We only have one demo right now. We've done a few things, but as far as what we plan to initially push into to upstream master is a web server. So we have an example of the web server where it's actually hosting content and all. So on the web page, you actually have the ability to see some live data that's interacting with like the time or the battery voltages or something, and actually display it on a generated HTML page. So sort of on here, the sky's the limit. It's just you have now full reign to talk IP. What I started testing on was I was working. I'm with Kraus Hamdani Aerospace, and we built some hardware for the upcoming Cube Red. So on the Cube Red, that has 2 sockets on the bottom, if you notice, and that allows us to be we can be backwards compatible with, if you don't populate that, we just have the Cube Orange in there. And then I had a little periph I was making where the sockets are. Am I not showing up there? No, yeah. I had a little periph that was in there that we were actually running the IP stack on a periph. So using AP periph, we're basically able to do everything that the aircraft can do. And it just gives you a much smaller, lightweight footprint to do everything that periph can already do, but do it with IP, right? So I was using this to do a basic UART to UDP converter. So on this, we were able to do some development, testing with this. Great relationship we have with QPilot. They're been a great help on the SID's working on kind of the lower level stuff, and I'm looking on a little bit higher level. So great teamwork on there. Some major to-dos. So things that we already know we want to do, but we're of course looking for whatever else you guys can think of. But IP-based bootloaders. So that's going to be a one we'll want. You can already do Mav FTP, so you can fetch log downloads, and now Mavlink is just better, faster, anyways. So you already have an instant better log downloads right now, but it's only like let's say like 2.5 megabits or so. We want to try and get that up times 10 at least, something. So implementing a way to really transfer massive files back and forth to your SD card and handle all those giant log files. Tons of room for improvement on optimizing stuff. So for latency, throughput, all that kind of stuff. There's lots of room for improvement we can do on there. We want to get some more HTTP examples. So get some more web pages in there. And I'll show you one in a minute, but it's good to show like I actually have images embedded in the firmware. So there's all kinds of neat tricks we can do with this. So get better examples of that so people can start building their own thing. But even better is having possibly a GCS or a lightweight GCS right in as a web page. So you just access the web page it's hosted on the device, and then you can maybe see plots, check your parameters, fiddle with things. The sky's the limit for modifying whatever you want at that point. You don't have a standalone computer. You can just talk directly to the aircraft. We'll be able to have much better interfacing with payloads, because a lot of payloads and cameras especially, they're all IP based for getting lots of data off of them. Now it gives us the ability to just talk directly to them and control them and whatnot. So that gives us a new avenue to really open up better support and encryption. So that comes back to the question earlier about SFTP and SSH and other things. So that's on the roadmap. We'll be doing that, but also just encrypting all your data and all that kind of stuff. The chip that's being used on the Cube Red, which is what I've been developing on, it's based on a CPU that has hardware acceleration on encryption. So this will actually work really well with that and not really take up any headroom for or it won't hold anything back. It's hardware accelerated. And pull request welcome, of course. So demo. Let's show you a little bit of a demo here. I have a cube on here, and then on my computer, I have a USB-C going to with Ethernet, and it's with USB to power the board, but I'm not doing anything with USB. I'm just using that for power.
We got a demo. I think you missed something right at the beginning. Why Ethernet? What is it useful for? What device is going to connect to? How are people going to use Ethernet on real digs?
Sure. Yeah. The question is the big why? Why do this at all? What does it give us? And so a lot of new radios are all expecting higher bandwidth, and a lot of those are all IP based. It gives you out of the box better like aircraft to aircraft comms, and lots of devices are also Ethernet. So it allows you to have to get away from the more ancient serial UART interface. You can talk to multiple devices now, talk to the ground, but it just much better integration with the system as a whole, and not having, bring us to the next generation of interruptibility with interfacing with other stuff.
And also co-computer, like if you want to send high rate IMU data to co-computer for whatever image, image processing they are doing, even for that, it's a quite useful tool, like to be able to say, high like IMU, like AHRS data or raw IMU data to fuse directly into your vision estimation. It can be a really helpful thing as well. So, just those VDS ROS, of
and
course,
yes,
yeah.
and DDS ROS. Yeah. So you'll have direct interaction with ROS, make your driver within the autopilot, don't have to do Mavlink conversions and none of that stuff. So that's really good. And then especially with the scripting capability, you can just interface to do whatever driver you want for whatever device is out there. So
yeah.
Thank you.
Yep. So ping, I have that down here. So yeah, so it's connected right now. So I have a static IP on my computer, and the Cube Red has a static IP on it. And so when I ping it, this is the rate. So one-ish milliseconds, 1.25 or so. And this is just out of the box straight. We're not modifying anything. It's just we kind of enable the feature of for the IP stack to say respond to pings. One thing I want to add to this is actually do a not just a ping server, but have the aircraft have a ping client. So you could turn it on and say, I'm pinging something. How long does it take for me to ping it? But so it should be the equivalent, but it'd be nice to switch roles there. So that's a bandwidth. Mavlink. So we have Mavlink, or we have Mission Planner. So as you can see, we're connected via UDP on here, and I'm just on port 13.14.4 right now. But you can see the hub. There's no GPS on this, so it's not going to show anything interesting on there. But as I move it around here, we're connected. It's nice and fast and all that kind of stuff. And then also when you boot up, it will show you what your gateway, your IP is, and that sort of stuff. So there's some information. And so when you connect with DHCP, it would also just populate that and say, oh, I just got a new IP, and here's the IP. So you should see that right there. Yeah, so that's that one. And then what else was there? It was the throughput test. Yeah, let's do that. Oops. So, you want to do website for HTTP?
Yeah, I think so.
Okay. So here, I'll just click on this and take me to there. So that just takes me. Oh, that's IP in wrong on this?
It went to Google.
You want to? No, I don't want Google to do it. It's not going to know this IP. Is it going? Yeah, it's going. It's refreshing here. It's been on for a little while since the start of the, so here's is our kind of just a default page that we kind of threw together, but the idea is it's got some logos in it that are actually stored in the flash memory. So there's zero access to internet on this right now. It's fetching all this.
Server running on the flash
So,
drive.
so this is the web server, and you can set the port to whatever, but right now it's 80. But the idea is to get some examples here of you see your IP or set it and then change some settings and whatnot. So we'll make this a little more fully featured to kind of give a good example of how to interact with parameters and that sort of thing. But just showing that's right here, just showing CPU time, but we could be showing GPS time or whatever.
And the server is written in Lua, of course, so it's running on Lua, so
Yeah.
it's not actually taking off time of the actual processing, it's taking off time of Lua. So it is running on Lua. It's
Yeah.
not, yeah.
Yeah, all the content here is Lua.
Is Lua. It's all a Lua socket library basically we have included. Yeah.
And then so yeah, so the idea is you can click buttons here. But we also have this thing, Mission Planner Express. So we thought it'd be nice to actually try to port Mission Planner over to HTML. So we thought, let's do that. So now on the aircraft, we have a full-fledged GCS that you do everything right on there. Oh, I'm sorry, this is our image. Sorry. Yeah, just kidding. Yeah, so it's just a PNG. But the idea is this is what's it, 2 megabytes or something PNG?
Yeah.
Megabyte, but that's it loading the whole image, you know, so we can just refresh this, and it's pulling down this 2 megabyte high res image off the SD card.
Not SD. Oh, yes, SD card.
Yeah, this one's SD card. Yeah, but we can do it in embedded flash, SDs, whatever. It's just whatever. So it's pretty quick to pull up a few megs of data, right? Or that's about a megabyte per second or so. But yep, so that's and then. Where did the presentation go? Oh, it's up here. Another one? Yeah, throughput. Yeah, let's do a quick throughput demo. Let me minimize this. And right here, I'm looking at my Ethernet. So it's getting, if you can see there, it's about 80 kilobits per second on the wire for my Ethernet 2, which is what we got here. And if I'm hitting reset on this, I'm clearing this. I'm getting about 7K of bytes per second. So that times 8 plus some overhead is what the 80 kilobits is, right? So now if I go over to the configuration and I look at like net underscore, these would be the parameters we have for net, but then I have a net 1. So on here, I have net 1 type 1, which is the throughput test. So I'll just turn it on. And the content is -1 right now, which means give me the hello world, whatever string, and then the duration. And so it'll actually do a throughput test with duration and then shut itself off. That way you're not just spamming yourself forever and mess up. And you can set an arbitrary what kind of size of packet you want. So you can say, well, if I'm only sending 10 bytes at a time, what's my throughput and so on. And then you dedicate. So I'm just doing a broadcast right now at 10,001 port. And when I say do it for 30 seconds, I hit right. And then over here, the throughput just kind of, so I was actually working on this before, because this bandwidth just saturated, it starts having mavlink come back and forth, so I get the ACK back on this one, but then it gets it, right? Anyways, so now we're actually up here pushing 86 megabits per second. And if I go over here, it's dumping out what it's getting as peaks and averages, and it'll run this for 30 seconds. And then it dumps out a summary. And so we're getting peak of 87. We're right in it just below that, 86 something, and yeah, total amount of bytes written. So that was 315 megabytes, right? That's actually what just went through it. So the capability is there to just do tons of data. We just need to connect some dots through the libraries to increase the bandwidth on that, or the throughput. And then I think that's all I got. So that's it. Yeah. Question, Randy.
So
What's the interface like, from a programmer's point of view? Are you still going to serial manager and getting, serial A, or how does it look like from a program?
So basically there are two ways we are taking this. So one is basically if you want to integrate the app directly into Azure Pilot. So it's behind the AP networking, basically module. But generally that common users will be like, if you are developing, serial, or you just want to send some data, you'll mostly be using just hal.serial. And in the bracket, you will from number 10 to whatever, considering that serial extensions are properly configured, is what you'll be using for your purposes. And if, of course, if you are doing HTTP or you're doing custom servers or custom clients, you'll be using Lua to basically set that up as well. So there's different ways, but the initial first wave would be this. I would try to get the serial extensions plus UDP over serial question, and then we'll, in the future, look at adding Lua support as well in the master. So
yeah, so right here on this one, we have the serial extension enabled turned on. So that gives us the serial A type parameters. So we have protocol 2, which is for IP. And so we're saying send your data to broadcast, and it is I'm sorry, serial protocol 2 means Mavlink. So it means Mavlink 2, just like the serial protocol. Yeah. Traditionally, it always says that. So we could, if it was like was a 5, not 5, it's a
5
9,
GPS.
Yeah, 5 for GPS and stuff. It's just the same thing, right? So 2 means we're gonna just be expecting Mavlinks to this, and then we say what port we're gonna talk to and IP, and then the PHY type is 1, meaning IP. 0 it assumes serial, but 1 is IP, and 2 will be drone CAN. So you could just say Mavlink at the drone CAN port or something. And then when you change this PHY, that also changes these up to be different parameters. So the idea is now with these, we have the ability to have a virtual serial port and then talk whatever protocol we want. So that's what we're doing right now to without any serial hooked up, essentially a device with no serials, you could have a virtual serial port talking Mavlink or anything else, talking to Mission Planner. So if you notice here, I'm actually talking on this port 13.13.4. That's what this is. So just a matter of, and then you can do another one. You can say, I want to send another stream. I want to do serial B and do Mavlink 2 to some other port. And so you're going to start doing multiple destinations. And
there's, of course, ability to do custom servers on Lua as well in the future, not now. So you don't even have to set that. You can just write scripts and do, your custom servers to do, I don't know, IP cameras and stuff like that as well. Yeah.
Yep.
I guess.
What hardware does it work on?
so right now there's, since I was working so close with QPilot, they've been really great. That's the Cube Red is, maybe you should talk about this.
Yeah, I mean,
This is your bit. Come on.
Okay. Yeah, so currently, so the first instance, of course, was done on the dev kit. Like we had the S757 dev kit, and just basically get our things what is actually required to make this possible, right? And after we did the testing on the S75 eval kit, which was the first example, then we moved on to actual hardware, which is Cube Red in front of you, which has all the things you actually need to pull this off, like extra flash and external flash and Ethernet actual physical modules that you are required to communicate. So right now we have Cube Red as a implementation, but as things go with Azure Pilot, I see it being implemented in more vital platforms probably in the future. But yeah, Cube Red is the current supported hardware for this. Yeah.
Does it work on dedicated as well? Still?
Yeah, I think so. We have a 757 example eval kit.
So who would apply to it?
Yeah. Yes. I think there was.
Yeah, I just had extension to that. So do you see it coming to Cube Orange, maybe even Cube Black one day, and there any platforms you've been able to say, rule it out, it won't?
Cube Orange, maybe through some AP Parif modules that we are actually planning on doing a Parif module as well, which will be able to convert. I mean, Philip is showing it off like some small tiny bit that you can potentially attach over CAN, which will be able to throughput would be just what CAN can support.
Sure.
But if you want to do some low bandwidth data just over IP, you can potentially do that. But yeah, because of the hardware, there was no target or goal for that to be like that. Like Ethernet is something that we have started working over the last year and stuff as well.
Okay, and then the second part of that is, that this might be ambitious, but when do you think your PR master might be, you might expect to support like majors? I know it's
Yeah, I mean,
crystal ball.
it's this PR that we are showing off is actually based on top of what was merged because it was pending, like the Chibios update that we recently did in Arju pilot. It needed that change to be able to actually add Ethernet support, right? So that has went in, and this current work is based on top of that. So it will require some cleanup. I am estimating at least 1 month to get in at least until the serial extension. So you will be able to connect at least serial ports over UDP sockets through the HAL.serial interface, basically. So that's my sort of estimate. But yeah, we'll see. Yeah.
So management of CPU usage. So I'd be curious, like during that bandwidth test where you're pushing more than 80 megabit.
Yeah.
What happens to the scheduling of other tasks if you turned on, for example, shed debug?
Right.
Do you see any task slippage?
I don't think it would be really good right now because we haven't looked through the priorities. This is something that we put together over the last week. So there's a lot of that kind of tests we still need to run. I had just normal sitting, doing modeling. I did that test. It was still at 757 was sitting 56% idle. So it's decent, but I think we can improve that a bit as well with our proper priority management and, that throughput test, I think we still need to do. But with normal modeling streaming, it was sitting 56% idle. On S7.
Users on
The last one? Yeah, so Chris just asked the question, like what is the sort of CPU performance we are getting if we run things like throughput tests and, stuff like that. So yeah, that was the question. And yeah, previous
related to that, protection against incoming packet floods affecting the stability of the flight control.
Right. So Ethernet actually has its sort of RAM, allocated RAM. So we actually give its own sort of RAM block, SRAM3, which is 32 kilobyte long. And it is, it uses DMA to just grab data from that particular RAM section. And it also puts the data in that particular RAM section as well. So it is supposed to just stay in that region. That is how the architecture of Ethernet is done physically. So you set the memory address, you want the data packets to come in. And so we just allocate that bit of RAM, and that bit of RAM is not used for anything else, just Ethernet. So 32K of that SRAM3 is just used for Ethernet. So it shouldn't happen from, the coming in or coming out. Where we need to analyze is the LWIP stack itself is not, consuming RAM where it's not supposed to. So my guess is we'll have to define a memory pool that it can use and have restricted checks around that so that it doesn't go outside of that. So that sort of safety we need to build into the LWIP stack rather than the lower thread, which is in the lower sort of HAL level, it's already built in. Yeah. Yeah.
I saw that looks like unicast is broadcast is supported. They also support multicast.
LWIP, I think it's it's a part of LWIP stack. So whatever features are in LWIP stacks should be supported multicast, unicast.
Yes.
Yeah.
Cool, thanks.
Yeah.
And the other question is, if a user has the choice between using serial or Ethernet for the same application, recommend using Ethernet?
Depends on the application. I mean, if you really require that level of bandwidth, and also the other side is also talking IP, maybe it's a good idea, but again, it depends on application to application. Ethernet, I would say like Ethernet is here to replace anything. It's just another, application that we can have in Arju pilot. Yeah.
Yeah, for the DES stuff, we support multiple interfaces. And I think
Right.
we're gonna maybe need to come up with some recommendations for you.
Right.
Which
Yeah.
interfaces prefer.
Yeah.
Maybe we'll have to do some.
We'll have to do some work on that. Yeah.
Does Lightweight IFB support any traffic shaping, QoS kind of stuff?
Sorry, QoS, well,
The question is does LWIP support quality of service essentially, right?
Yeah.
Not that I know of, those are all things that we could, that can be added to it. The intent of LWIP is to just kind of for the IoT world, where it's just kind of gives you the thing with least amount of resources. So I think there'll be a lot of things that we'll be adding to it, such as that and proper FTP and other and stuff like that.
Okay. Yeah. Sorry. So LWIP library is in GPIOS. So LWIP is actually, so the question is LWIP part of GPIOS. So the answer to that question is no. LWIP has been around, I think, before even GPIOS. So it's its own basically library, open source implementation. What GPIOS has is nice little bindings that were implemented right into the GPIOS to be able to use LWIP. So yeah.
But I think to answer your question more directly is the code for LWIP is in the modules GPIOS folder. So it lives in GPIOS repo.
Okay.
Much like we did the FAT file system. So the FAT file system isn't actually part of GPIOS, but it's an add-on that is tightly integrated with GPIOS. And LWIP is in the same fashion.
So, the STM32 boards have never had a camera interface before, and by adding Ethernet, you basically give them the ability to talk to a camera or even get a video stream. I mean, that's not gonna work though, right? I mean, we're not gonna have the CPU on the STM32 boards to do any kind of meaningful image processing or anything like that, right?
So the question is there enough processing power basically to be able to handle video stream, right? Over IP.
Pictures, you know,
I would say the answer to that question is no, at least for now. Maybe forwarding we can do it, but I would say like, why would you do that rather than just connecting directly to wherever you are forwarding to? So I would say handling, yeah, but you can control it. So I have actually run an example where I was using the GSWAP, whatever mess that is, to actually control an IP camera using RGB palette running on STM32. So sort of I ran the antenna tracker to be able to just control the camera in wherever direction you want to point it to. So that sort of worked. So I was able to achieve that goal to be able to control IP cameras angles and stuff and focus or whatever. So you should be able to at least do the settings of the camera.
And sorry, the reason that it would be really amazing if you could do that is that it means that the RGPilot developers within the RGPilot development environment and we could do more stuff. Like maybe we could merge optical flow or something like that straight into RGPilot. I'm not saying I wasn't expecting you to say yes.
So as far as handling data that has video, images, whatever, and then doing processing on them, the processing power, I think it is capable of doing that because you can kind of do it at whatever, as long as you're not trying to do it in real time. The issue is we just don't have any RAM to do any of that. Like even doing like real time JPEG decoding and encoding is going to be really hard to do that with a 1 meg type memory footprint, right? This is not the target to do your processing. However, I do think there's probably a future that we could do some things where a picture or a camera has internal storage, has a terabyte of whatever flash or SD, and then it's taking pictures and storing them, and then somehow we could sneak in there and maybe change the metadata on them, and do things like that. I think that'd be a potentially possible thing we can do. It just depends on how much processing of the JPEG we need to do, and how fast it's being generated and that kind of stuff. So it's one of those things where that's just, it's all on your wrist at that point of just making a Lua app or whatever to talk to a file system on some other drive. And
I guess to balance off of Randy's comment, maybe a good intermediary would be something like a Jetson Xavier, so have Ethernet to Xavier and then have the camera to Xavier.
Yeah. The question is adding extra GPU or whatnot. Yeah. So if you're wanting to process video and stuff, you'd want to just have something with gigs of RAM and GPU Jetsons and whatnot. But at this point, the autopilot can be anywhere on the aircraft, and it can just be plugged in with Ethernet, and it can be just done anywhere, right? So
fill up, yeah.
On that one, if we have a healing section directly via Ethernet, for example, with a switch in between and you've got the Ethernet camera in there, the setting will video out through the healing, but you might be adding some
Control. All right, I'll move to the Drone Can update quickly.
Okay, yeah, well, so, yeah, Sid and I will be around all weekend, of course, you can come. I'm sure there's gonna be lots more questions.
Yeah.
But there is this other thing we wanted to try and squeeze in, and it's called another presentation.
Yeah. So just a quick Drone Can update. So over the last year, what has happened, sort of, I'll do a quick intro. Basically we have 4 modules that we are actively working on. So DSDL, PyDrone Can, GUI tool, the DSDLC, which allows you to generate Drone Can DSDL messages into a C code, which you can use. And of course, libcanart, which we use as a decoder and encoder of our messages and putting them on the CAN bus, right? So I'll just give you a brief about each of them and what has been going on over the last year. So we have added few messages in DSDL over the last year, like there's serial over CAN message sets that has been added. We have OpenDrone ID over CAN support now. And there are a few more actuator support, new actuator message sets that have appeared. We like to have, like most of the manufacturers to use the existing actuator message sets, but I know there are some limitations and we sort of need to fix that. Hopefully we'll have features like extensions in the, so we can basically improve our current message quality. But yeah, prefer to use existing actuator messages rather than, coming up with a new message set or whatever. So it's good for, the ecosystem and also for the maintenance of the UAV CAN drivers. Of course, there's an addition of battery monitoring message as well now. So we have a big, battery monitoring message where people can, manufacturers can use and send, smart battery data over Drone Can now. So that's good. So this is, we actually talked about it before in networking talk. So the serial extensions, where you can basically select what type of physical layer you want to communicate your serial over. And it sort of gives you that opportunity for Drone Can as well. So this is still work in progress, and you will have ability to send serial packets over Drone Can and be able to use the HAL.serial API to do so. Yeah. Few improvements to PyDrone Can and GUI tool as well. So we have fixed all the Python, the Python version issues that we had. So we had build fails and all sorts of weird stuff happening with the newer Python versions. So that all has been fixed. And we have added support for CAN-FT in Socket Can, which allows you to sort of do testings in Linux systems with RGPilot running on CITL. So previously we only had support for normal CAN packets, the 8-byte packets, but now we can do it for CAN-FT packets as well while using GUI tool to analyze that while it's doing that. And of course, there's a support added for marbling to signing in GUI tool so that you can basically connect to a signed marbling and be able to securely access remote CAN device, remote vehicles with CAN devices as well. So few improvements to Drone Can DSDLC as well. We have fixed some bugs in Drone Can DSDLC. So it's nothing that impacts existing message sets. So all the existing message sets are actually not using these sort of combinations. So we don't have those issues existing in our message sets, but in the future we might. So that's why we have fixed these 2 issues that we had. And we have also added support for generating wrappers around the encoders and decoders, which are C++, which allows us to do some fancy stuff that I'll do a brief discussion about that later in the slides as well. There's few improvements to libcanart as well. So we have added support for, setting what the deadline for the transmit is going to be, which we had in the libuav CAN, the, C++, like the C++ implementation of Drone Can. So we have added that support for libcanard so that we can replace that whole, heavyweight implementation of DroneCAN. And we have also removed the old deprecated TSTL generator, which was actually generating broken encoders and decoders. You're not supposed to use the inbuilt generator that was there in libcanard because it has not been maintained for a while. So if you are using that, please avoid using that and use the DroneCAN DSTLC generator. And we have removed it entirely from the libcanard, so no one actually mistakenly uses it. And also we have added support for redundant CAN/FT sort of interfaces. So libcanard initially was only able to handle, one CAN port at a time. It has no idea of having like multiple interfaces sort of as a backup. But now it has that feature. So basically these three things make it feature complete as far as replacing libuav CAN is concerned, and which is the next step we do, is to actually remove libuav CAN from ArduPilot because of its heavyweight and complex nature, and replace it with a nice C++ wrapper around libcanard, right? So this is what I have been working on for the canard, right? So we have this C++ wrapper around libcanard, which has, basically it is physical layer agnostic, which means you can, right now it's doing CAN and CAN/FT. In the future, it will allow us to add different interfaces, right? Like it can be, I don't know, serial, Ethernet, or any other, shared memory like interfaces that you want to have instead of CAN. So this makes it nice and easy to do that because it just abstracts out the interface layer in front of canard. And I've tried to reduce the use of templates so that we are not just adding unnecessary flash costs just for the right of simplification and abstraction. So it has been, I have done this in a way that I literally looked at what is the cost on flash and RAM is going to be with each of the template addition that I've done in the code. So it's been written in a way that it is lightweight, but it still is powerful enough for people to use in a simplified way. Of course, it's lightweight, and it basically gives us 65 kilobytes of memory of flash back in ArduPilot that we can reclaim and use it for other fun stuff. Ethernet, yeah. So yeah, I mean that flash space is going to be key because we are actually getting close to flash running out of flash even on 2M boards. So this saving is going to be very, very useful for ArduPilot. And of course, a simple loopback test like there has been missing in libuav CAN implementation in ArduPilot to be able to just use CITL to test its own sort of UAV CAN drivers. So that is a simple feature that should have been had from the day dot, has been added, and we can now self-test all the UAV CAN drivers in CITL without needing any external sort of requirement of socket CAN or all that stuff. So that is a nice thing that has been added as well. So size compare, as you can see, 65K of flash saved in our source of vehicle, except for Blimp, which probably doesn't use much of UAV CAN drivers. So this is sort of a comparison of what we were doing before and after. So as you can see on the left, the red is the before code. I'm not sure if it is quite visible, but as you can see, it's like a complex sort of template structure that people had to write, and it, sort of repeating their own sort of message, and it's just room for error in that is actually quite great. So this sort of makes it concise, and just a single line can easily make you subscribe to a message. So you just write allocates about callback, and it will just infer the message type you want to handle from the function itself, and it will create all the boilerplate for you without much cost in flash. I have forgotten the numbers, but it's very, very tiny, and that's why we are getting the flash gain that we got. And basically just do all the boilerplate for you. as compared to what we do in AP Parif, which is just, you have to write at least 3 different functions, edit 3 different functions to be able to handle a message, right? Whereas this gives you a nice and compact API to do so. So this is basically a new way to subscribe messages in ArjuPilot world. Hopefully we can bring that to AP Parif. I'm not sure, but I would like to. This is a list of upcoming work in DroneCan. So I want to finish serial over DroneCan. I want to add node capabilities in ArjuPilot and all the DroneCan world. So hopefully it is part of the wrappers, the libcan art, so that other basically users of DroneCan can also use it off the shelf. We want to add message extensions, so be able to add messages, add fields into the messages, which is not present. Basically, if you want to have a new sort of field in a GPS message, you want GPS time in weeks or something like that. It's just not possible. You have to just come up with entirely new message sets, which is sort of painful. So we will try to change that and make it easy to do so. So that's something that we want to work on. And I want to basically create applications in libcan or C++ wrappers as well, so that the DroneCan users basically be able to use features like dynamic node allocation, time sync, parameter management, and all that stuff right off the shelf, rather than every time implementing their own. So that would be a useful thing to have. That's one of the things that libuav can sort of had going for it. But unfortunately, due to its complex nature, I don't think many consumers of DroneCan were actually using those techniques. Even in ArjuPilot, we almost always had to write our own sort of implementation for everything. So that would be good to have as well. And of course, more tests. We want to test whatever we are doing in DroneCan space so that it is, basically, always working and not breaking. And yeah, probably add Ethernet as a physical layer to DroneCan. So that would be a good thing to have as well. So yeah, I think that's about it. Any questions or any more discussions? Or
This so sounds like startup DroneCan V2.
Maybe. we'll call it 1.2. It's
evolved DroneCan.
Yes, replace DroneCan compatibility. Yeah, I would call it 1.2 rather than V2, because we want to do incremental changes. Maybe V2 would be some extra big feature that comes in. We'll call it V2, but incremental changes make it compatible with what we already have. And I don't think it's a good idea to play the number game anyways, like V1, V2. I mean, it's just application, what application needs you have, and we need to work towards solving those problems rather than just,
There's a precedent for Mavlink too.
Yeah. There is. Yeah, we can do that.
Encryption, we can call it.
Yeah.
Basic question about what kind of nodes is the impact intended for, and who would do this?
So the question is, what kind of nodes is the DroneCan intended for? So DroneCan is basically a intra-vehicular communication protocol. So any basically actuator, sensor, or active system in your basically vehicle you want to talk to or exchange information with, it's for that sort of purpose. It's not meant for off-board comms. It's not meant to be used like a Mavlink, for instance. So it is for intra-vehicular communication basically, and it's supposed to be scheduling.
Actuators.
Right. So priorities, I think that's what you mean. Like, who decides what the priority of the message? And this is something like right now, I think it's very ad hoc. Like every sort of manufacturer sort of defines their own priority for the particular message sets. There's of course the message ID as well that sort of governs what the priority is going to be. But generally, it's up to the manufacturer to decide what the priority of the message is going to be. Is sort of bad. I think it would be a good idea to have sort of that as a, I don't know, parameter or configuration in the future for users to be able to choose what the priority of the message that is coming onto the bus is going to be. So that is something I do intend to discuss with, all the other drone camp.
Question
partners, yeah.
scheduling as, even if I decide the priorities,
Yeah.
who does the scheduling?
It's inherent to the CAN bus. So if you look at the CAN bus protocol itself, based on the node ID, the arbitration happens at the node ID level. So it happens on the wire level. It's not done by a central, a scheduler or anything. So it's baked into the CAN, and that is where CAN is a pretty good protocol, where it allows you to basically manage priorities and scheduling based on the message ID. But we should probably at least give some ability for integrators to be able to set those configurations, and that level of granularity is still not there, but hopefully we can get there eventually. Yeah. Nothing else.
So, thank you very much, student Tom. For an hour. So can't get out, stretch your legs, fill your stomach, enjoy the food that's up the back there, and be back in an hour. So at 2 p.m. Please be here a few minutes early to make sure that we can get started on time. We have 3 talks coming up this afternoon, and after that, this evening, we've booked a cafe restaurant right on the lake, which should be very nice. And all welcome to come along to that at the end. I'll give more details about that. It's in the chat, but more details at the end of the session. So thank you all and enjoy your lunch.